Recording in progress.
And don't hesitate to come closer. So for everyone who's still having a coffee or a tea or a juice, if you could please come forward so we can start. There will be other coffee breaks. And if you can pull the people who are still outside inside, that would be good too. So let's get officially started. Welcome to all. Today's day of conferences and roundtable is mostly roundtables. The idea is really to have exchanges, discussions between obviously the participants to the roundtables, the speakers, and the audience. So of course, feel free to be ready to ask questions. The way we're going to do it is that I will call on stage the panelists. The first session is about research and development for renewable and alternative energies. And we will have three smaller sessions. The first one is about solar, wind, and hydro generation. The second one will tackle the matters of batteries and electric motors. And the third one will be about back. So the way it will be organized is that the panelists will introduce themselves briefly. Please keep it short and sweet. And then we will start the discussions. A quick reminder, please turn your mobile phones off. That would be good, or at least on silent, to make sure that we're not disturbed in the conversations. And for the first panel, I would like to call on stage Mr. Mathieu Michou, who's the managing partner of Watt & See. Please, Mathieu. So you've got a microphone which you need to turn on. And take one you want. And yeah. Then I'd like to call on stage Mr. Luca Bonci, the CEO of Solben. And we will have Mr. Simon Vatin from VPLP online at some point when he manages to connect. Unfortunately, due to well, some COVID issues, which is still around, and also some airport issues, some of the attendees and participants will join us online rather than being on stage. Test, test.
Good morning.
Okay, so we're ready, and so we've got our three first panelists, as I said, to talk about solar, wind, and hydro generation. And the objective of this first session is to look at the evolution of the technologies, the solutions, and what can be expected in the near and long-term future in terms of evolutions of such alternative solutions. And so first one to have a quick presentation is Mr. Mathieu Michou from Watt & See. Mathieu?
Good morning.
Floor is yours.
Thank you. So I'm Mathieu Michou from Watt & See. We are a small company located in La Rochelle on the west coast of France. And since almost 10 years, we are focusing on developing hydro generators. These are devices to generate power from the water speed only on sailing vessels, and so we regenerate power from the water. This is very useful on racing boats, and we began the company on this field to help single-handed sailors, like on famous race like Vendée Globe, to generate the energy for all the electronic onboards like autopilot and informatic and telecom. And since 7 and 8 years now, we are focusing on a range for sailing, cruising sailing vessels, mainly for families that travel all around the world and also need to produce their energy on their sailing boats. So these are small device, small power, like 500 watts, but this is enough to power the boat and make them in autonomy, like a small house. More recently, we also have developed a range of wind turbine aimed to the racing market, so that are very small and very waterproof, as opposed to the wind turbine we can find on sailing boats currently. And well, this device must be used in conjunction with other system of production, like solar panels, because it will work only when the boat has some speed and not on the mooring.
Thank you. Luca, if you want to introduce yourself and your technology.
Sure. Good morning. First of you, thank you for the invitation. I've been following this event since from its very beginning, and I'm always very glad to be here. And I have to say that from the beginning, I mean, the event really enlarged a lot. At the beginning was just solar racing, and now there is full electric, there is hydrogen, there is wind, there is everything. This is really the event to stay, where to follow the development of renewable in mobility, marine mobility. Okay, Solvian is an Italian company. I want to stress from the very beginning that we are a manufacturing company. We started in 2007. We just started with an idea of a famous, at least in Italy, but maybe you know Giovanni Soldini is a skipper, and he had the idea to install solar panel on his racing boat. But at the time, also nowadays, the standard solar panels are sturdy, are rigid, are heavy. They have glass and aluminum frame. So the idea was to make something different. And the idea was to make something that was possible to adapt to the deck. And so we started with a trial. We developed a solar panel with the standard solar cell, I mean the cell that are used also on the roof, but with a polymeric encapsulation. So very thin, adaptable, and okay, this is the beginning of the story. Actually, Giovanni won the race. He said that he won the race because he saved the weight. He didn't have any fuel, just solar to power the electronics. I think Giovanni won because he was a winner, but from this beginning, so we were born in marine. We started to develop, we increased, I mean, we developed the product more because at the beginning it was not so durable. And in 2010, we founded this company. And since then, our market enlarged a lot. We started with racing boat, mainly sailing boat, because on a sailing boat, I mean, to have energy without a generator is something that is much more important. But especially in this last period, we are receiving a lot of requests also from yacht and also from shipping. I mean, also cargo shipping, we are developing projects in this. This is just the beginning. But for sure, solar, in the meanwhile, become one of the most valuable energy source, not only in mobility. And naturally, we are specialized in mobility because we cannot compete with the large solar market. And okay, here you see, I like to show this picture because this is Energy Observer, as you see, and the other one is Malizia. So we are playing in the house of the boat. This is yeah, I think you know Energy Observer. This is a kind of paradigmatic boat because there is solar, there is wind, there is a generator of hydrogen, and there is naturally a fuel cell to use the hydrogen. Okay, so this is Solbian.
Thank you, Luca. And is Simon online with us? Can he join us? Is he around or not yet connected? Yes, he is connected. Simon, can you hear us? We can see your name on the screen. Okay.
Hello?
Yes? No, not yet.
Good morning, everyone.
I think we heard you briefly.
Hello, everyone. Can you hear me? I can hear you loud and clear and see you, actually. Nice to see so many people around.
Can you hear him fine? Yeah? Okay. So, Simon, if you can briefly introduce yourself, your company, what you do. I think VPLP is quite a well-known name in the industry for all the sailing aspects of things. But if you want to tell us a bit more about it and your latest developments, and then we can start with the questions we've got for the panel.
Yes, sure. So apologies for the delay. I'm just trying to get some good connection here. But glad to have the opportunity to be around with you, at least virtually. So yes, we are a 40-year-old now naval architecture firm with quite a story in sailing and racing yachts design. And since about 10 years, we have
Market especially, and generally to the yacht boating market. Who wants to take up that question first?
I will try to answer first on the sailing vessel market, because we only operate in this market now. What we see is that the efficiency of the sailing boats are more and more enhanced by the modern study of architects and especially on the sales, and this results on more speed on the boat, so more energy to recover from the water stream. So what we see is that the trend is to equip all the sailing boats by a system to produce their energy, and they need a panel of complementary systems. So that's why we are together around this table, because on all racing boats we equip together with most of them with hydro generators and solar panels, because none of them, it's difficult to have the autonomy with only one of the system. And this trend is quite universal, and because intrinsically renewable energy cannot be sufficient to get the autonomy to system for mobility or for terrestrial use. So yeah, I think we will see more and more system like ours, like hydro generators on sailing vessels, and what we see is also their architects are thinking from the basis of the concept, how to integrate the energy and the production of energy on the new boats. So I think they plan to have a lot of surface to integrate solar panels. They plan to have a location on surface to integrate a hydro generator as well.
Thank you. Luca, you want to have to, yeah?
Yeah. First of all, I truly agree with Mathieu that, I mean, integration is what is needed, not only in mobility, but also also on the land, or the other application, renewable, need to be integrated one to the other to reach real goals. From the point of view of technology, I mean, in the last, I've been in the field for 20 years, and I have to say that more or less the technology that were there 20 years ago are here. For the solar, you know that there are different kind of solar cells based on different material. We decided, in Solbian, we decided actually 10 years ago, I was in the field before, to use crystalline silicon solar cells because they are the most available, most diffused, and reliable also. There are other solutions, and but more or less, I mean, I don't see any real breakthrough in the future, because even if the technology is not so new. Solar cell, the first solar cell commercial available, were made by Bell in 1954. For long years, there was just, I mean, not a curiosity, but a small utilization of that, because the cost was very high. What happened since the 2000, so in the new millennium, that there was a strong industrial development and the cost decreased a lot. And together with the decrease of the cost, there was the increase of efficiency. But there is a theoretical limit of the efficiency, so we are reaching a plateau. I can say that the efficiency of solar cell in this last year was surprising in my view, because in any case, every year it's increasing, maybe 1%, 2% every 3 years, something like this. But we cannot think that the efficiency is going to be double. Also because, I mean, we cannot have more than 100% of conversion. Now we are, in commercial cells, we are at 25%. In the satellite one, that maybe are also here, I don't know if someone is using gallium arsenide, but we are at 30%, but we cannot think that we are going more than this. What happened is that the prices really crashed down, and now solar energy is far the lowest cost mean of production of electricity. I'm not talking about yachting, I'm talking about large solar system, but the cost of electricity produced by solar is 1/4 of the cost of the electricity produced by coal, which was the cheapest before. So it's really a revolution. It's just matter of time, and solar will cover large part of the electricity, of the energy need of the world. Naturally, it cannot cover everything, because the sun, and during the, during the day there is the sun, during the night there is not the sun, and so we need integration, so we need the wind. I'm just speaking generally, but everything can be moved to yachting. So we need wind, we need storage, and altogether I think we can really go to great result in using just renewable energy everywhere.
Thank you. Simon, are you still with us?
Sure, yes, can you...
So
yes,
you heard the question,
okay?
yeah, about developments and how do you see the future developments as well? Can you brief us on that?
Yeah, it's, as far as wind propulsion or wind solution are concerned, it's a very exciting time today, because we see a lot of innovation, a lot of new solutions that, you know, actually come from yachting or yachting educated entrepreneur that really put forward a lot of creativity and a lot of technical progress. We see solid wing sails, we see inflatable sails, we see suction sail coming, and as well as kite, which have been around for a long time. But they, we can really see a lot of solutions that come up, and they're really able to serve the different typologies of vessel, be it for a smaller high performance yacht or day cruise catamaran, for instance, or a small vessel, a small commercial vessel, a large fishing vessel. Each typology of vessel will have their preferred solution, and it's as a naval architect, it's an extremely exciting time to try to ascertain which type of rig or wind propulsion solution, if we want to call it, is going to be the most adapted to a project. And we see real efficiency gain in terms of and significant fuel consumption reduction. And the last point, the last new point, which is also brought forward by innovation and new technology, is that we are able to design and to propose yacht or vessel that have a significant wind propulsion aspect to it, to someone who actually would, in normal time or 10 years ago, would only buy a motor yacht and would only be interested in motor yacht. No, you have modern rig and modern wing sail or sail solution that are more and more automated and less impacting on the use of a yacht, for instance, and you're able to talk to someone who would never, you know, not really a sailor by heart, but actually let them know that, well, if you put that wind special rig on your boat, you will save 30%, 40%, 50% of fuel in your daily consumption. You're able to cross the Atlantic, for instance, with your yacht if you want, which you would not be able to do. So it really brings a lot of new interest and interest in people that would not really be hardcore sailor as well. And to me, it's very important to be able to open to a wider audience by the use of this new innovation. So this is a bit really where we stand on the wind propulsion field today.
Thank you. Well, so you think that the three of you are seeing a trend towards a wider adoption, even in the yachting world, of alternative solutions, with people being more interested in reducing consumption and looking at their energy savings. Is that something that you said is a trend, but can you see that as something that is really taking up amongst the yachting world or in the boating world generally? Whoever wants to react to that.
So we change. No, yeah, it's taking place. This is taking place also in larger yachts, not only on sailing boats, not only on small boats, also larger yachts. But not everything is done. Not everything is done. I think that I already said that from the point of view of technology, I mean, the solar panel are ready and the efficiency will increase, but will not increase so much. But the point is how to install the solar panel, how to use the energy, how to cooperate with other sources. And this is really a lot of things have to be done, because now we are following several projects of large installation yachts. But it is not easy. I can tell you, it is not easy. Everyone is a different project. The way or the space where to install is different. You know, in boating this is normal now. I mean, every sailing boat is different from the other, even if they have the same name. But we need a lot of development, not only from us, but also from electric engineer and marine electrician, because at the end you have energy. Architect, Matthias said, architect need to think to find the space where to install solar panel. Now it's also easy because now multi-hull are fashionable. Multi-hull, there is a lot of space compared to the other kind of yacht. But I mean, it is not trivial. It is not trivial. You know that there are already solar yachts that they are made in a different way, no? They have large roof. But after installing the solar panel, you have to do the wiring, and you have to use the energy, and the energy maybe you have to power a high voltage battery, or maybe you have to interact with a genset, with a generator. So all this part is, I would say that is still in development and need to be done. This is really what we need to do now, not to increase maybe 1% efficiency of solar. They will come by itself, but to integrate in the right way is the way to obtain more energy. If not, you will obtain 1% more of energy efficiency from the cell, but you lose everything because the integration was not done in the right way.
Thank you. We've got the naval architects and the shipyards this afternoon, so I'm sure they'll be able to take up on that matter.
Yes, and concerning the trend, I think what is interesting to see is what is going on the merchant ship market with, as we can see these years, more and more projects of sailing boats that are designed for merchandise transport across the ocean by sails. And these kind of projects were a bit crazy 10 years ago, but now we see that the feasibility has been demonstrated with first prototypes of sailing cargoes, and also the architects worked on a lot of concepts for the sails and the wings for these merchant ships. And I think this is a good preview of what could be then transferred to the leisure market after.
So basically you're saying that one of the drivers is the merchant shipping, the actual maritime world, that helps drive forward also the R&D side? Or do you see other drivers, and we talk about the yachting world here, enabling you to push forward the experimentation and the development of the solution? That's something that maybe Simon can answer?
Yeah, I think I agree with Matthew. It gives a lot of visibility and credibility, but I would say the innovation goes both ways. As I said, as far as, for instance, wind solution or wind, modern rings are concerned, the innovation is driven a lot by the yachting. But when you see, this, it's applied to cargo ship and merchant ship, then the amount of engineering and R&D and that is applied can come back to the yachting, and by maybe one of the simple knockdown effect is cost reduction. If we can see this going forward in terms of more series of rigs, for instance, then we will have some price going down of such equipment. I'm thinking a lot about masts, for instance, rigging, and then can be applied to a greater range of projects. For instance, one of the funny case that we have come up with is we had a design project for a sailing cargo ship, which was 40 meters, and it was for a very remote region of the world. So they wanted something really low tech. So we were looking at aluminium mast, 30-meter aluminium mast, and we realized that actually no one is building 30-meter aluminium mast anymore since 20 years because all the yachting has moved back to carbon. So today, making a an aluminium rig of this size, for a large aluminium rig, is the same price or more expensive than a carbon rig. But for a cargo ship, carbon mast is very scary, and they want metal. So at some point, and it hasn't really been decided today whether now aluminium mast will be back on Mars because that's what the cargo industry wants, or carbon mast will actually be a new norm and accepted by the cargo industry because it's been proven in yachting and in sailing in general. But there's been that funny moment where we say, actually, you want us to come back to an older technology because you're scared of the new technology, but the older technology is actually much more expensive today because no one is doing it anymore. What do you want us to do in terms of as someone innovator? We struggle a bit with that kind of question, but the cargo, the shipping world takes quite a bit more time to move on this question. But once it has moved, then the scale effect are really massive.
Thank you. Two of you actually mentioned already the issue or the question of cost. We're talking about the solar panels and the cost of production being reduced dramatically over the past few years. To what extent the issue of cost, the economic impact of the solutions, as far as your area is concerned, has a strong impact or limitation to your own developments? Is that something that is changing, or your R&D is being basically slowed down because of matter of costs associated with it?
I would say for us, for our company, the problematic is a bit different because there is not a lot of alternative, and mainly we operate on racing field and long range sailing fields, and on this market the cost problem is not the first one, because if you want to cross the Atlantic or make the race around the world, you have to produce your energy. Otherwise, you cannot reach the end of the race. So that's what we began as Solbian and Luca on the racing field, because there is much more budget to address these problematics, and for the leisure market, we managed to cut the cost down to a certain extent, but it's remain an expensive technology, and so economically it's far to be competitive against diesel or fossil energy. But since there is no gas station in the middle of Atlantic, then you have not a lot of alternative if you want to cross with lot for the usual comfort on board on sailing boat. So and to finish, I would say that now the problematic of cost seems to go in the other direction, with components that are today more and more expensive. So I'm not sure we will try to reduce the price of the products, but it looks like all the manufacturers in the marine industry now, we have to increase the price of our device because of the raw material price. Luca?
Yeah, sorry. I have to say that from this point of view, we are quite similar companies now. You are small companies. We are behaving as European companies. I mean, small volumes, big customization, big specialization, and I always say that we are a tailor shop more than a solar panel manufacturing company. But it's clear that we are already targeting different markets, and when a yacht is coming and they want to have a full solar system, maybe 30 panels, all I mean, it's clear that you are not paying solar panels, you are paying the service, you are paying the project, you are paying everything. When you go to a cargo ship, we have to discuss in a different way. We have to cope with the fact that for them is a cost, they have to save fuel, but also the goal is different because on a yacht you need to drink, you need to cool your wine or beer, it depends, I prefer wine, but when you go to shipping, you need to save the world. So it's clear that you cannot save the world if it costs too much. And so, yeah, I mean, there is the path to cost reduction. If you are going to different market, you are going to different volume. And we are doing this, and we are doing the calculation like if you were cheap. We are not, but maybe we could be in the future, we could increase the volume for some market.
Okay, thank you. You were talking about the complexity of implementation on board the vessels. To what extent do you find that when you do your R&D, the complexification of technology makes it difficult to basically have the wider adoption? I mean, this will be a question that will be also asked to the other panelists for the next roundtables. Are people afraid of the complexity of what it means to have an hydro generator on board, to install solar panels, as Simon said, to maneuver sails? Is that something that brings a limit to the adoption of your technologies?
For our company, we had to fight this fear about novelty and innovation, but it was more than 12 years ago. So now it's well adopted, and the initial fear was more concerned about the drag and the loss of speed of the sailing vessel. For the racing vessels, it can be understood that the drag is a big concern, but it was also a big question for all the cruising market. But now we have demonstrated since more than 10 years that our technology has not a big impact on speed, and so there is no such fear about installing the products on new boats. But I think it's probably not the case on more innovating technology. Maybe Simon will tell us about the wing cells, and probably they have to fight some concern about this innovation, because people don't know how it works and how it will behave in strong wind, on all these questions that everybody can have.
Thank you, Simon.
Yeah, for sure. If I can bounce back on what you said, Mathieu, it really depends on what kind of actor you're talking to and what kind of solution you're bringing. For instance, if you're talking to a sailor who has a gunboat or a high-performance catamaran, they would be interested in innovation in terms of new rig or new mast shape, and they would not be afraid of having an extra set of line to trim the sail or the camber, for instance. But obviously, talking about cargo ships, this has been really the challenge to try and put ourselves in the customer's shoe and say, okay, they're used to having, they don't know about sailing, and they're used to having push button engine that make that work when you turn them off, and that stop working when you turn them off. So that's really been the driver to validate and to push forward that innovation, to say, look, it's automated. You are not going back to the old clipper with the lines and people going on mass and etc. We really had to do a lot of education about this and on the use, but also on the usage, but also how it impacts the vessel. So to short answer is yes. There's a lot of, especially in the cargo sailing market, there's a lot of breaks to innovation, but generally our main argument is also on the cost, saying this cuts you down fuel yearly operation cost by 10%, 20%, 30%, depending a bit on the project. And this is really the main point that these people want to hear about and think about, because as Lucas said, they are not they're just transporting goods, so they try to make a business of transporting goods, so they offset the investment cost with operation cost, and so it's, to answer, it's both, it's innovation, it's usage, but it's also a cost efficiency for this.
Thank you. One last question.
Today it works. Usually people understand. Oh.
Sorry. One last question for me, and then we'll ask the audience if they've got some for the three of you. If I were to ask you, within the next 10 years, how much, in a way, in a percentage, I know it's not an easy thing to do, but how much of, I would say, increase in efficiency or cost impact and/or adoption by the wider industry or the yachting industry will you foresee in terms of what's in the end the potential for your technologies to unlock its full potential? Or have you already reached we were talking about the fact that the technology for solar panels has not really evolved. So, how do you foresee that evolution for the next 10 years?
On our technology of hydrogeneration, I think we are already quite high, and I don't see a revolution on next years, because we are on a mature technology. We use a propeller design, which is very known for maybe 6 or 7 decades. We use electric generators from the industry, so that are already optimized, even if maybe we can get some additive percents of efficiency. We use electronic converters that already have unbelievable efficiency with only 2 or 3% of losses. So there is a little energy to recover from the system. But on the contrary, I think I believe we will see a bigger adoption of the system. This is for the moment the limit. So we equip a small market only on boats that have a mandatory need on hydrogeneration because of long travel. But yeah, since the trend is to equip in standard from factory due to the architect design and also the boat builders design, we will see a more massive adoption of such systems.
Thank you. Luca?
Yeah, I have to say that what I see in the future is, I mean, we are, as you said, we have a mature product, but we are just at the beginning of the learning curve for the integration in mobility. Solvian is not anymore just marine company. We are acting in several other markets. Imagine that 25% of Solvian, even if we are a manufacturing company, so we have people that are doing the panel, 25% is a technical department, because we are not enough, because we have to interact with as we said, with the people from the other side. So because we need to develop new solution to install, to integrate, and then there will be standardization. So it's really still a long path. Actually, we are hiring. If someone wants to work in Torino, we are very happy. And no, really, but I think the potential is huge.
Many students down there.
Yeah.
I'm sure of interest to you. Yeah.
No, the potential, just because the potential is huge. Because you see how many panels you see around, not so many, no? And in automotive, trucks, ambulances, whatever. I mean, it's huge.
Yeah, so the difficulty in your own potential or unlocking the full potential is more on the integration, the difficulty, the complexity of integration, especially in mobility. Yeah. Okay, great. Simon, a comment on that, on your perspectives?
Yeah, for us, yeah, I guess for us, as I said a bit at the beginning, the main perspective is really try to bring sailing or the sail aspect to people who would actually only have a motor yacht, being motor yachting. That would be a huge potential on our side to bring these people to use the wind as a propulsion.
But in terms of the technology, the potential of the technology, I mean, improving the efficiency in a way, what you did, for example, with the Ocean Wings, do you see other perspectives of development that will make it easier, faster to integrate as well? Any revolution coming?
I would say a bit like Mathieu and Luca, the physics and are known, and the aerodynamics on my end are known since a century. So there isn't going to be a revolution in that. The potential for improvement is more going to be on real-time control and trimming and automated trimming of the sail, especially for vessels that have more than one sail, to make sure that all of the time we have the optimal performance of the sail of the device at any moment.
So in a way, it's making the complexity. Is making the complexity of operating a sailing vessel, making it simpler for everyone all the time.
Exactly.
Okay, well, we'll talk to the naval architects this afternoon about this as well. Any questions from the floor, from the panel? From the audience? Yes, there's one hand. I don't know where's the mic. There's 2 hands, 3 hands. Can somebody bring them a microphone? See? Please, I don't know, there was one earlier. I will take one from here. It works. Take mine, whoever.
Test. Yes. Yeah, thank you for the discussion. By the way, my name is Guido Loef, head of R&D of FedShip, so one of the naval architects. Mainly a question to Luca, I think. First, introducing it, yes, we do see as well that photovoltaics make a lot of sense for super yachts. They follow the sun, that's a good thing. There are several projects in development with very substantial solar panels, like 30, 50, 100 square meters even. But there are challenges. Costs are quite high. You may generate 50, 100 megawatt hours a year, which is a lot of energy, but it's only 1, 2, 3% of the energy use of the super yacht. There are so many more things you can do to reduce the energy consumption, which are at much lower cost. So therefore, the capital investment may not be the main issue. However, there are so many more things you could do which make more sense, so to say. But anyway, that said, still, you see that investments are made. Technical challenges are aesthetics. So how do you make it look good? We look at, for instance, the glass double curve panels produced for solar cars or electric cars. Make also a lot of sense, or even the bonnets and all the other surfaces. So I wonder how you look at that. What are the innovations there to really look it smooth, like the yachts look like? And also, what developments do you see in order to get to other colors? Because aesthetics are really important. You don't want some sort of patchwork around your super yacht. It may be deterioration towards the efficiency, of course, of the panel, but it may be important to address it as well. So, material and the look of the panel. What are the developments you see there?
Yeah, actually, we have a lot of solutions from this point of view, and I want to start from the cost. we can. I think, as I said before, I mean, we are expensive. We are a tailor-made company, and the point is that we are the beginning of the story. And so with the development, I really hope that the cost is going down, because I mean, we are quite aware that the cost can be blocking in some market. About aesthetic, yeah, we are quite aware that people want to have something that is aesthetically nice, or even better than nice, because when you go to see, I mean, a yacht is something that is perfect, no? The people want to have perfect. We are working with other companies. We also developed some several options. For example, our panels, they can have a different kind of surface. They can be glossy, they can be matte, they can be embossed. And this is what we can do now. Imagine that in any case, we are still a kind of artisanal company. I mean, we have a factory, but we are not an industry at this point. So you have to consider, but also yachting is artisanal, no? You have to consider that this is made by hand, and so maybe it's not perfect, but it's enough. And we also developed the masking technique that you don't see the cells. We can also offer white panel or gray panel. I mean, you don't see the cell, you just see the same color of the deck. We already did something, we did blue. Actually, you are losing some power, because if you change the color in front of the cell, you mask the cell, but some of the light is lost. But there are techniques to lose as less power as possible. So we are for sure working in this field, and this is one of our characteristics, that we are offering a lot of different kind of panel, a lot of different kind of electrical solution, a lot of different appearance. Naturally, there is a limit. You can also have white panel. If you want to have white panel, you lose half of the power. Can be okay for someone. I mean, you don't see anything, just see white, really like this shirt. So, I mean, it is possible. But from my point of view, when I say, I like to see the cells. I'm fond for solar. I like to see this is a solar panel. But if you want to cover, we can.
Thank you. There was a hand raised. Yeah, there were a few. So it's all towards the back, if you can. Thank you. We only have time for 2-3 questions. So try and keep the questions short and sweet, but especially short.
Okay, here's a short one. You talked a lot about integration. What are the challenges and opportunities you see in the future?
Simon, maybe, if you're still with us, you want to answer that?
Integration in the sense of, I'm not so sure I understand.
Okay, can you rephrase the question then, please? Or develop a little bit further.
Between us or on the vessel? Which kind of integration? I think this was the question, Simon, no?
I mean, you have different power sources, you have different applications, different boats. So you talked about complexity. How do you integrate it into the operating vessel?
I guess this is a question we can leave for this afternoon's sessions with the naval architects, the engineers, and in fact the integrators, and something that we will also talk about when we deal with the batteries and electric motors and how these technologies are evolving. So keep the question in mind, and then we'll get back to it. There was another, yeah, still at the back.
Good morning. A question for Luca. In terms of heat, heat is the enemy of solar panels because it reduces their efficiency. Are there thoughts of using that heat that's generated from the solar panels as another source of energy?
Okay, this is for sure. I mean, solar panels are made to absorb solar light, so they heat up. But I have to say that also black surface. It's very hot under the sun. Usually, this is something that is done. For example, there are hybrid panel in standard market. I mean, glass roof. Usually, the heat that you produce is too much compared to the surface that you need for solar. Just an example: if you have a house, you need 20 square meter of a solar panel for electricity, but you need only 2 square meters for hot water. And so this integration is something that it's increasing the cost. Okay, if we speak about houses, it's much easier to have more solar panel produce electricity and heat the water with the electricity than to produce electricity with the pipe or stuff like this, because it's simpler. Electricity is just a wire. If you have a thermal solar panel which is heating the water, you need to have pipes and etc. etc. So all electric, it's easier.
Thank you.
Sorry, can I just come back on that point? I agree in terms of use in a house, but on a super yacht where you might be where you're not so concerned about just water heating, but using that energy, that waste energy, for heat pumps, for heating swimming pools, for all sorts of energy sources on board the vessel, then that waste heat could actually be invaluable. And I am aware of a project that's using that waste heat to increase the overall efficiency of the solar panel installations up to about 45 to 50%. So that's a huge increase in energy.
Okay, no. This is a more special application. It's clear that can be done. We go back to the previous question. Help us in integrating. I mean, we are making solar. Someone has to think about the other part.
Thank you. Charles and then Jeremy, and then we'll stop these questions. You can always continue the conversations when we have a break, because we're a bit behind time, even behind the initial plans. So just these last two questions, okay. Short. Please.
I'll be quick. It's for Luca again on solar. You mentioned cost a lot and the costs coming down. As a supply chain question, how much of that is a China factor? Because in the news recently, there's a satellite shot of a solar factory next to a mine, next to 3 coal power stations. So how much of the life cycle, not just the energy efficiency from the solar panel, how much of that is out of balance, and where do you see that going?
It's not easy to answer. I mean, I can tell you something about there is a long history about people that were against solar. No, that for a long time the people were telling that the energy that you are producing with a solar cell is not enough to cover the energy that is needed to create the solar cell. This was just wrong. Was completely wrong, because the energy payback time is 1 year. Okay. And so it's clear that if you produce in China, and in China they have a lower cost of electricity, I mean, at the end the payback is smaller. But in any case, it's very positive, the energy balance. Because imagine that the solar panel of the Bell. There are solar panels that are in the field for 40 years, and they're still producing. So you can say that after 1 year you recover the energy. You have 30 years. To produce other energy for the other solar panel. I mean, so from this point of view, I don't know if I answered your question, but I mean, this is a...
Thank you. Jeremy, last question. And then our panelists, if you have one last message as well to convey to the audience. Simon, you're still with us?
I am.
Yes, hello, Jeremy et Odev. That's a question for Simon, VPLP. Could you please share with us the amount of project increase you have in the last months? Because I just heard that there is a new French tender about 20 boats that want to have a selling solution. And could you please also advise us about the difference of the techniques by using a textile sails or some, let's say, metal sails? Because I am very concerned about the two type of technology, and I think if we want to have an integration on yacht, being light and being retractable is something very interesting. And it looks like most of the, let's say, big merchant ships, they go for not using textile, but mainly using a metal wing sail. So can you please give some experience about it, please?
Yes, I think what we have to understand is when we, especially on the larger project, it's difficult to compare a yacht to a cargo ship, in the sense that basically a yacht is going to be able to be powered, say 100% in terms of propulsion by a sail, whereas when you design larger cargo ships, you're looking at auxiliary propulsion for sail, so 10, 20, 30%. So for the yacht, basically, you're carrying so much more sail area per mass that you have to be able to furl and to reduce. So you have to go textile. For a cargo, you have a much lower say to mass ratio for most of the project, and certainly the larger vessel. So you can allow yourself to have something that is much more rigid in terms of not necessarily furlable. You can just feather it in the wind, or you can just twist it. So really, it's technologically, it's a path that are splitting, if that can reassure you. And or said another way, I really don't see any kind of metallic sail application in yachts. I don't think that's the way the way it's going to work.
Okay, thank you, gentlemen. Thank you. One last word. You have something to convey, or we leave the floor for the next panel.
Yeah, thank you to all, and yeah, we hope to see more and more hydro generation and solar panels on boats on next year to see if our prevision are good.
Yeah, I agree, but I want also to say that I just arrived. I'm very curious to go to see the boat, to see if there is something new, and I will be around today, tomorrow. So if I'm open for discussion and everything.
Thank you, gentlemen. Give them a round of applause. Thank you. Merci, Simon.
Thank you so much.
And so we go straight on to the next panel. And for the next panel, we'll be talking about batteries and electric motors. And so I'd like to have Rory to join us on stage for Vita. And Jan Olaf, who's going to be this time, will be about Nordic batteries. So the idea about batteries and electric motorization, it's basically to look at the evolution also of the technology, of course, its implementation and the barriers to development, but also the potential. There's obviously been a lot of technological developments in batteries, not just in the automotive world, but also on board boats. Even though there are some other issues, we'll be asking these gentlemen about these issues as well. But there seems to be a lot of competition in a way when it comes to alternative solutions with the proponents of batteries and then other solutions such as hydrogen and of course wind. So this is why I invited this gentleman to tell us a bit more about the evolution of technology when it comes to batteries and especially its future evolutions. So I will leave them to introduce themselves briefly, and then we can start the questions. Have you got a slide? No slide?
Well, while they find the slides, I can just, here we go.
We got a
First, I'd like to be back again because I come originally from the electric car sector. We created the very first European electric car company in nearly 20 years ago, and I actually won one of the first Monte Carlo rallies for electric cars here in Monaco in 2010. And that was actually important because an electric car is a systems integration, and I fully agree with Luca and the others that the key challenges is to be systems integration companies. We created them and now also Nordic Batteries, so two companies in Norway doing that. SEM started actually as a consulting advisor company to ship owners to say how you could use the battery technology which we use from the car industry. Until 2016, where one of the ship owners said, "I hate consultants, why don't you just do it?" And I'm sorry, we are 7 people, we are advisors. Well, why don't you just make a bid? And we bid then for one of the ships, which you see on the picture there on the left, a big supply vessel. And we won. We competed with ABB and Siemens and others. And since then, we started just developing customized battery solutions. At the moment, we have 50 vessels equipped, 20 now on process, and we can talk more in the afternoon about the technology behind that. But it's very important that we see the opportunity to adapt technology which is proven by other areas. My key message is that the cost is important, safety is even more important, and there's a very strong effort on making very safe systems. We had of the 50 vessels that are running now since 5-6 years, we had never a single accident, no thermal runaway. And that has to do a little bit with the technology. Each company, each system is in itself a battery room. So it fulfills all the requirement by DNV and others to be a fully safe entity. So if something happens inside, it is contained within one single box. Nothing can come out of it, and that has proven very well. In the respect of Nordic Batteries, which we created last year as a spin-off, we are involved in customized mass production. We believe that there is a very strong need for specialized batteries for different applications. The Brits say horses for courses. Each horse needs a certain course. The same thing is also for the vessels. Different vessels need different types of batteries. And what we're doing with Zemmon, we're doing with Nordic Batteries is actually specializing, customizing, and mass customizing different types of battery technologies to different applications.
Thank you. Rory? Hello. Wait for the slide to come up. My name is Rory Traher. I'm the CEO of Vita. Our mission, we were founded about 4.5 years ago to reduce the impact of recreational and small commercial boating on the marine environment. We develop fully electric powertrains for boats from effectively sort of 3 meters up to around 14 meters. And we develop a range of high-performance all-electric boats from a 3.5 meter jet ski up to our 7 meter rib and a 10.5 meter all-electric luxury day boat. Both these boats are here today, down on the water, so I won't bore you with who we are and what we do, but just come down, have a chat with us, come out for a spin on the boats, and I'll explain to you what we're doing.
Thank you. So, well, my first question is like for the previous panelists is basically the evolution of the technology over the past 10 years, and INLF mentioned, what came from the automotive world. So can you tell us a little bit more about the speed of evolution of the technology, but especially what's coming up in the future? I mean, you did mention different battery technologies. I don't know if everyone is well versed into the different types of battery technology that are applied or used in the maritime world. So if you can give us, either of you or both of you, a quick overview of what developments have taken place over the past few years, and especially what you're expecting for the future. We'll talk about cost and other aspects afterwards.
When we started, actually, we had the prices of batteries per kilowatt hours are extremely high, and really for specialized applications. At that time, we decided to go with batteries which the other parts of industry had already approved, and that means the car, the heavy-duty equipment, and the truck and bus industry. So we chose MNC, and we are still sticking with MNC. We have a project with LFP and also one with LTO, which is a very high technology and high effect battery. But most of the people ask, how many kilowatt hours can you store in a certain space or in a certain weight? For initially, the weight issue was not so important. Now we are equipping fast vessels, catamarans. We have equipped what is today the fastest catamaran in the world, which is still not very fast. At that time, it was 35 knots. but there suddenly weight was very important. So this balance between weight and efficiency is right. In the future, I think it will be still MNC. That technology will be most popular because that's the one which is used most in Europe. Except the Chinese, they prefer LFP, but in most European companies and American companies go for MNC.
Thank you. Rory?
Well, I mean, as a business, we've been around for 4.5 years. I've been part of Vita for 2.5. So I can't give you a perception of sort of a 10-year cycle. In terms of what we've seen in battery technology, yeah, we use third-party battery suppliers. We don't produce batteries ourselves. Certainly, the sort of interesting area for us is cell development and availability of cells. I mean, that's actually one of the major challenges at the moment in terms of supply chain. But you know, there are cells, there are batteries for different components. We want loads and loads of power because we want to not compromise the experience of going on a boat and be able to go around fast. Other applications want longer life cells that are going to provide lots of energy for less sort of high performance applications. But certainly, you know, we use multiple different battery manufacturers, and you know, the cell development and I mean, fast charging is central to our business model. We've always been focused on storing as much energy as we can on shore, being able to have a high performance application and fast charge. So the faster the cells can charge, the faster we can get someone back out on the water and doing what they want to do.
Thank you. So from what the two of you just said, I heard two things. Mass customization, I find the concept interesting. Obviously different types of technology, and one of the drivers or limitation being charging. Can you tell us a bit more about
Well, I mean, so we Vita have a sister company called Aqua Superpower that's rolling out a network of high-speed 75 kilowatt DC chargers. I mean, there are 2 in Monaco, a couple in Ventimiglia, and all the way down the coast here. The great thing about adoption of electric boats is that every marina's got power. Okay, in some marinas it's 16 amps, some it's 32, and if you park here you can charge at 75 kilowatts. But that means that the availability of electricity to fuel to power boats, whether on an overnight charge or a fast charge, means that the adoption rate should be much higher, because we're not having to, you know, and hydrogen's a whole different conversation, but to get hydrogen pumps into marinas is going to be quite a logistical challenge. So yeah, we see fast charging, and there's an element of range anxiety, as anyone who's got an electric car will have been through and hopefully got over. But you know, people will have that with boats as well. But if they know that there's you know, an operating network of high-speed chargers that mean they can charge from 10 to 80% in 45 minutes, which is what we're doing on our big boat, then that takes away that concern.
So your impression is that fast charging will help, in a way, limit the limitation of the range provided by batteries, because people will be able to recharge fast. You think that's the way the future will evolve?
Well, batteries are heavy and expensive, and you know, you've got an option. If you're very happy operating in relatively close proximity to where you want to go boating, which a lot of people do, they go out of here, they go around the corner to Aires Plage, they go to have a huge lunch and come back again. And for that, you don't need to carry a load of energy. But if you want to go to Cannes or Saint-Tropez, you need to carry the energy and you want to charge on the way. You know, certainly one of the limiting factors for us is our big boat's got 1.2 tons of battery in, and that's what we need in order to get to Cannes or Saint-Tropez, different speeds.
Thank you. Yanov?
I think it's a very interesting comment, because it happens all over the world in all sectors. ZEM is owned today, majority owned by Volvo Penta, so we were focused on ships. And last summer, the Volvo Group came and said, well, you know how to make batteries in ships. We have a problem. We are launching electric construction machines, and we have decided on the highest level, all vehicles, all buses, all trucks, and all construction machines must be electric within 15 or 20 years. We don't know how to charge them. So they asked, can you use your marine technology and set up charges for us? And obviously, as optimists and entrepreneurs, we said, sure, we can do that. And we worked like hell for 6 months, and we delivered in May the first 10-foot container for fast charging of construction equipment for Volvo. And they liked it, and they just ordered 15 more, and then they asked us, what would it cost if we ordered 100? So suddenly we see a big business, and they said, perfect, we'll use that same technology for charging and supporting charging. And we talked to Aqua Superpower and said, listen, in many places you have good chargers, but does the network to bring the electricity to your chargers, is that good enough? So basically what we're developing now are backup storage, we call it trickle charging, where you charge up a container, and when the vessel comes, you have enough electricity and enough energy to move quickly. So I think using, again, technology from another sector into the marine sector, and in our case, vice versa, having marine technology used on land, and now also suddenly on trucks, is very interesting synergy. So I fully agree with him. The big challenge is make available fast charging when you want to pay it, or overnight charging if you have time.
Yeah, thank you.
Thank you. So in terms of the technology itself, the different types of technologies, we know, as you said, it's heavy, it's costly. How do you see the evolution in the coming years in terms of, in a way, not the efficiency of the device itself, but its cost to efficiency ratio, and especially when it comes to weight as well? Any evolution, significant evolution can be anticipated, because we know these are the limitations of batteries today.
Well, this is probably more for Olaf to answer. From my understanding at the moment, there's not a silver bullet that I'm suddenly going to get a 60 kilowatt battery that weighs half the weight of our current batteries within the next 5 years. And certainly for, price points, obviously a factor. The per kilowatt hour price at the moment's high. It's uncompetitive. But that's also because the marine industry is small. We are producing a low volume of boats at the moment, and we're competing with the automotive sector. So it's very difficult for us to get a really competitive per kilowatt hour price, which is fundamental, which is where I would say 60% of the powertrain cost lies, probably for us, and that's going to be to some degree the barrier to entry. We're going to have to wait until that per kilowatt hour price comes down with volume and with improvements of technology before we're going to see mass adoption.
So you're saying basically what people, even in the yachting world, what they look at is the price per kilowatt hour?
It's what we have to look at commercially as a business. One of the advantages we've got with the yachting industry is that they're less price sensitive. And what we're doing is providing powertrains for super yacht tenders. Now, the advantage, your average super yacht tender is probably between 1.5 and 3.5 million euros. So to factor in a 50% increase in cost for the powertrain component for that is an easier thing to bake in. The challenge is when you're trying to sell a 7-meter rib to a port to replace their Zodiac, and the price point is unobtainable from a commercial standpoint.
Okay, thank you. Let's get back to the technology then, Jan Olaf.
I think I can give you a little bit hope.
Please do.
In the future. Because again, ZEM and the production part of Nordic Battery, ZEM is majority owned by Volvo, and suddenly we benefit from what's happening in the other sector. Volvo has decided to develop a next generation battery, and we've been managing to get the right to use that battery on the marine sector. That battery at the moment we have about 1 vessel a week equipped with the existing technology. With the new one, with the same technology, the same size, we get instead of 66 kilowatt hours per unit, we get 94. So it's a substantial savings of efficiency. Not because we've developed it, because somebody else needs it for buses, for trucks, for others. So the idea, again, to benefit what others are doing and adapt it to the marine industry is our key entity. So we are just getting the DNV approval of that for marine, so there might be hope for you early next year. But you might stand in line because many ships would like to have the next technology.
So basically you're saying that the potential for use of batteries on board, it still has a lot of potential because the technology will allow for higher storage capacity. To what extent you think, I mean, to what extent we're far from the ceiling? Or when you say you increase by 30% the capacity of your battery, is it for the same size and weight, I suppose?
It's for the same size and 10% more weight. Which is, and again, it's not because of us, it's because other people need that and we adapt it. But as people said before, systems integration and integrating that in the vessel is quite a challenge. So that's what we have to specialize on. But always benefit what other people's need to do in a larger scale. I mean, we are a small company, having equipped maybe now 20 vessels a year is small compared to producing 10,000 of trucks and buses and so on. If we adapt that, we can benefit and then give it to the industry.
Which means then the cost will go down, which was one of your points, right?
Absolutely.
Rory?
Yeah, I mean, I think, you know, to your point, we're sourcing batteries from the automotive sector. So they come in a defined packaging because they've got a customer who says, I'm going to build 2,000 trucks. This is the battery we want. And I ring them and say, we want to build 10 boats. And they're like, lovely. That's very interesting. Here's the battery. But I think, you know, the more that the marine industry embraces, you know, electrification, the more that the battery manufacturers see demand from this industry for more modularity. I was having a discussion with Derek last night about the need to have more, you know, smaller units, so there's ability to chop and change and be able to, you know, store a battery bank on board the mothership, get that ready. If there's high demand for the tender, they can swap it in and out. I mean, that's a complicated process in itself, but the industry is going to demand it more and more and have more flexibility. You know, we've looked at whether we could produce a battery that's specifically designed to sit in the bottom of a hull. I mean, the certification costs are $750,000 to €1 million just to certify a single unit. So it's just, you know, it's not something we can do at the moment.
So what are the limitations then? Okay, we talked about weight, we talked about price. Obviously, the potential for the technology to be more, to provide more storage within the same space. Integration is an issue, also complexity. What about the origin of electricity? Do you ever get asked that kind of question when you think about battery technology?
All the time, yeah. I mean, it's a challenge for us. We want to electrify yacht tenders because it's an obvious use case. The mothership is generating electricity. I would argue excess electricity that then can be put into the tender and therefore, you know, hopefully using some of this excess energy to, in turn, reduce the impact of tender operations. But yeah, I mean, it's, you know, we with Aqua, we've developed a system so we can provide 125 kilowatt charging in 6 locations on a mothership. So it's, you know, it's a charging station for 6 electric boats. It's awesome. But, you know, ultimately, how's that electricity being produced? And same on land, you know. France is good because it's got a lot of hydroelectric and renewable energy and nuclear, but America's not.
We are a little bit spoiled. I'm Norwegian, and we are 97% hydropower. So we are not asked that anymore. But obviously, I know in other countries that is a main key issue. So again, we have to use the energy as efficient and as good as we can. We have some interesting projects on fish farms, where they said we'd like to be, the fish farms are getting further and further. Now it's getting after the oil, maybe the biggest business we have in Norway. And there they said we started looking at, can you generate electricity out far, far away from the coast with wind and solar and others. So suddenly the idea of generating energy becomes quite interesting. And then maybe fuel cell in the next round.
Thank you. Question on the safety and reliability. I mean, we know that also the lifetime, the number of cycles you can have on your batteries. Are these evolving in a way that you'll be able, what you were talking about, like easily replacing batteries, for example? What's the evolution on that front in terms of replacement, extending the lifetime of batteries and these kind of considerations, including safety?
I mean, so the batteries that we get DNV certified, so we're meeting the regulations already. So that's sort of one, the safety component. Unfortunately, the media are getting terribly excited, especially in the yachting industry, about batteries burning down super yachts. Yeah, that's another topic. But all I would say is that the battery fires that are occurring on yachts, a high proportion of them, if not all of them, are because these mobile batteries that are coming in and out of toys. They're not being charged in the right way. They're not cooled. It's mishandling of batteries in a marine environment, which is causing the problem. And they're not certified. And but unfortunately, that's now coming across to us, where we've got actually DNV certified batteries going into boats that are meeting the regulations in terms of integration and installation, and fire suppression and ventilation and all of those good things. So yeah, we're getting a bit of naysaying, but that's okay. It's to be expected.
So it's not so much the battery the issue, but it's the environment and the integration and the complexity of it also, probably?
But also, as you said, as the competence of the people on the boat, how to handle it. I mean, most of the accidents which I know of have done is partly because of mismanagement, that somebody saw a little fire, turned off everything, and also turned off all the ventilation and all the pumps, which is stupid. But he hadn't trained, he just turned everything off, and then the whole thing started burning. So again, the competence of the people, how to handle those situations, is extremely important.
I mean, to your point about longevity, one of our batteries is certified for 3,500 charge cycles. That's 0 to 100%, which is not a recommended way to operate your battery, and very unlikely anyone would do it, especially in the marine environment. On a calculation of a yacht doing a single season, yachts tending to be within 5 nautical miles of shore and operate. We've got some amazing data from a few yachts about how they operate their boats. I mean, you're looking at 15 years, by which time the tender is going to need a pretty major refit anyway. And I think that leads on to another point, which is just because that battery has had its life as a high-performance battery for a tender, to whiz a tender around, it doesn't mean to say it's totally redundant thereafter. It can be reapplied to domestic storage and other things. So, the battery has an afterlife after yachting, after it's retired.
Thank you.
Yeah, I think we are a little bit in a different situation because we are working on industrial boats, which means boats which are used quite heavily, ferries and others who go all the time and have to have at least 10-year life in 40, 65 days a year operation. So for yachts or super yachts, it's more relaxed, that's right. The question about Second Life is coming up also among our customers. We have a project sponsored by the government to look at Second Life activities.
Thank you. I'm sure there's plenty of questions from the audience. Okay, one hand there. Two. I start there, and then we carry on. And please try and make the question short.
Oh, that's a very difficult question. Yes, again, Guido Loef, FedChip. I guess a question for Rory. The issue with safety is a real issue. It's not only publicity. There are reports on fires, it concerns the flag surveyors, and then they need to deal with it. So what will happen is that we will have strict regulations with respect to storage of toys and tenders, electric toys and tenders, on super yachts. And those will be quite severe, to be honest. So you can't store them anymore in a space adjacent to an engine room, which they all are pretty much. You have to interface with the battery management system. You have to interface with ventilation systems. You need to have ATEX ventilation systems, detectors, all that sort of stuff. So we have to step it up. Your part of the industry, our part of the industry, and we have to collaborate. Are you aware of this? And how do you approach this problem?
Very aware. Are you aware that we're building the first pair of powertrains for the first pair of super yacht tenders going onto a Fed ship for launch next year? So I think there's an amazing collaboration already between your team, our team, and the tender builder that's involved in the project, and in fairness, the client and the project management team, who have all been really kind of central to making this happen. So I'm well aware of the discussions that have been going on between Lloyd's, between yourselves, between our team on the technical side, specifically around battery safety, battery storage, ventilation, both while the boat's in the water charging, while it's in storage, whether or AC or DC charging. So it's been complicated. I mean, one of the major things has been concerns over storage of dual, different fuel tenders. That there is an issue about having a diesel and an electric tenders stored in the same area. Thankfully, on this project, we've alleviated that because they're doing all electric tenders, which is awesome. But I don't know the details. In fairness, I'm not involved at that sort of technical level, but I know it's well in hand.
The good thing is that this afternoon we will have the classification societies attending a panel, so they'll be able to tell us a bit more about these severe requests from the installation of electric tenders on board yachts. Thank you. There was another. Yep.
Yes, good afternoon or good morning. Mr. Willems, this question is for you. You produce all these electrical boats, but do you use hydrogen technology as range extenders on those vessels?
In a way, yes. The in original boats we had were supply vessels for the marine industry, and they basically want to have a 300 to 500 kilowatt hour extra battery, which would allow them to turn off one of the engines, the diesel engines, when they're out at the platform, at the oil platform. So it was really a range extender, and also to comply with rules. DNV that time said whenever a vessel is out there, it has to have running 2 engines all the time. In case one breaks down, you have to be able to maneuver. That could be avoided by saying we have one engine and one battery, which takes over in that case. And also what we call when we have to have positioning all the time. At the moment, we have experience now with the first vessels in 5 years. On average, they save about 30 to 40% of fuel by using that. They save also money because probably like here, when you come to land, if you turn off in a harbor your diesel engine in a normal ship and go all on electric, you pay much less fee in the harbors. So in a way, we started with the range extender, and then came the ferries, and now we have a number of full electric vessels. But many times it's combination, a diesel engine for the long distance, and then a electric activity on the service vessel when they are down on the fishing or at the fish farming entity. Nice and quiet.
Yeah, we'll delve further into that with the next panel about hydrogen, and also this afternoon with the shipyards and the naval architects. Another question? Okay, there's 2 more.
Yes, in fact, I have 2 questions. I don't know if it's for Wilmus or maybe for Rory. The first one is we are all concerned about this energy transition, the life cycle assessment. And I see that there is more and more concern about the recycling, about the batteries. Are you already working in an idea about recycling the battery, which we all use for the automotive industry, to reuse it for boat, and after maybe looking for another third life for the houses? That was my first question. And my second question is more for the safety concern. I'm sorry, I don't know the exact word in English, but l'emballement thermique.
Thermal runaway.
Yes, because we know that we were also involved in some boats, and we see that regulation, especially on hydrogen, is something, but on electric it changed a lot also in the past months due to what happened in the coming years, in previous years, sorry. Do you see that there is a sort of temperature request to monitor this emballement thermique?
Thermal runaway.
Yes, coming in the coming months and years.
DNV is very strict on that, and all our vessels have to be approved not only for the system itself, but at the vessel at the very end, it has to go to approval, and they check all that. So we have to make 3 tests with our battery systems for thermal runaway, 3 full tests with the batteries, and it has to be able to not have a thermal runaway, and uncontrollable thermal runaway. We know our batteries consists of different submodules, and we have to prove that one submodule within the pack is not igniting or developing the neighboring. So basically, when we have had the test, they open the whole thing, and they have to see that only one of 15 units is burned out, and all the others have to function as before. So the rules are very strict. So I'm not concerned. As you said, it's very important that you have liquid cooling. We don't believe in air cooling, because liquid cooling makes it much safer. The other thing, as I mentioned in the beginning, each of our packs of now 94 kilowatt hours is in itself a battery room, although it's only 170 times 30 times 70 centimeter big. So it is a mini room where we can control all the things. We are required to control all the temperature all the time, regularly. Actually, we are required to comply with GDPR, so we are not allowed unless the captain agrees to measure all the temperatures. But we can do that, and when the captain says something doesn't look nice, we can take over from our office in Høvik, which is DNV headquarters, and control every minute what's happened.
I think just to the life cycle point, yeah, we've been doing this for 4 years. It's still fairly early stage. I'd love to get to a point where we can use batteries that have had a previous life or a previous application. I think the key thing for me is they've got to be certified. Right now, at this early stage of this industry, I can't afford. I've got a responsibility to our company, but I've also got a responsibility to us as an industry, the electric boating industry. If we start putting batteries on boats that are not certified or fail, it destroys this whole sector before it's even got off the ground. So there's a whole life cycle piece about the boats and the manufacturing process, which is, as soon as I've got bandwidth, we're getting into. But right now, I need to build a product that's safe and reliable, and then that's stage 2.
I just add to that on the quality. DNV requires not only that they check the battery, but that we also document that the battery producer follows certain quality rules to do that. As mentioned, we are majority owned by Volvo. They have requirement that whenever we have finished a vessel, we have to have a plan for second life before it will be trashed at the very end of the life. So.
Thank you. One last question. Quick one, please.
Yeah, hello, my name is Julian Melot, CEO of Zen Yachts, and I have a question for Rory. We talk and we hope that the energy density keeps improving. When I go out for shopping for my solar yachts, what I realize is that the market is going the other way. The energy density is decreasing. I see the main battery suppliers going away from NMC, and they want to push LFP, which is roughly 15–20% less energy density. And that seems to be the reality based on some incidents that happened last year. And so everybody is freaking out with NMC. And like you say, don't want to destroy this market, right? So I would like to hear your experience and where your procurement is heading in that sector.
Yeah, I mean, we've got a particular partner who's doing DNV certified batteries. To some degree, we are at their beck and call in terms of the direction that they choose to take. I've got to, be very open and admit that our CTO, and we've got a power division that's run by, we've got a second CEO who runs the power division, so I'm not intricately involved in the procurement process and technical discussions with all our battery suppliers. But yeah, I mean, we're obviously pushing them because we've got demand from our side, from the consumer side, about the level of performance that they want and expect. There's obviously a huge chasm between everyone's assumption that they can go from here to Saint-Tropez and back in a boat, at 30 knots, an electric boat. But, we've just got to manage that, not just have to get to lunch a bit later. But I can certainly introduce you to our guys and have a discussion, see what their experiences are.
Thank you. Thank you, gentlemen. Sorry, I'm sure that you'll be able to carry on the conversations with the audience, the participants, when we have a coffee break, which is not yet, because we're behind track on time. The next panel will be about hydrogen. And before we welcome the new panelists, if you please give a round of applause to these two gentlemen. Thank you. So for the last session before the coffee break, we'll talk about hydrogen, evolution of hydrogen-powered solutions, and also about storage of hydrogen. So I'd like to have Mr. Pierre-Emmanuel Casanova, who's the co-founder of ICLab, to come on stage. And then Jérémy Lagarrigue, who's the CEO of EODev, and Mr. Sébastien Benoît, the CTO of Inocell. I'm putting a bit of pressure for you guys to move swiftly. And we'll try and keep that panel also short and sweet so that you can have a coffee break afterwards. We're basically at least half an hour behind time. We started half an hour late, but we're beyond that. So I leave these three gentlemen to introduce themselves briefly, and then we can start the discussions. Who wants to start? Well, Pierre-Emmanuel is meant to be the first one on the list.
It's Sébastien. Oh, me? Okay. So, good morning, everyone. I'm Pierre-Emmanuel Casanova. I'm the co-founder of ICLabs. So at ICLabs, we developed a unique liquid hydrogen carrier. So instead of storing hydrogen in its gaseous state, we developed a kind of a sponge, a liquid sponge of hydrogen. Thanks to this, we can use the same infrastructure as the one used for conventional fuel. So basically, you can store and deliver hydrogen as you used to deliver liquid fossil fuel before. Thanks to that, we can save up to 40% of GHG emissions, and we can save up to 30% of hydrogen costs related to all the logistics around the hydrogen. So that's a technology that is really well adapted to the maritime industry. So that's why we are now very happy to be proud of being part of this conference today. And then we will move forward to the question then. So thank you.
Jérémy?
So, hello everyone, my name is Jérémy Lagarrigue, I am the CEO of EODev. Today EODev is a world leader in electricity production out of hydrogen with a fuel cell generation base for land application and marine application. And you have two demonstrators, one here which is powering all the dock of this event. We have a generator that you can see and visit. We are just producing water and basically the water in order to store the hydrogen in the case that you produce hydrogen with electrolyzing and heat. And the other one is a range extender. So basically it's approved in principle, by the way, and we are finalizing the type approval for the marine application. And this you have I guess one of the example down to the stairs of the Yacht Club of Monaco. We are giving a power from 10 kilowatt up to several megawatt. The first boat we designed was a Innova boat. It was a tender last year presented here. That was the first hydrogen certified and commercialized. But now we are working on a almost 200-meter boat, which is, let's say, not a passenger, but a cargo ships, using liquid hydrogen, because liquid hydrogen is a way also to increase the power density and efficiency about hydrogen. So That's the next step of what we are working on. And today we are happy to share that the total cost of energy about our solution are equivalent to diesel, and depending on the use case, we are also more competitive to diesel without any emission, without any pollution. And I guess that's a part of the future and why we are here in this event. Thank you.
Thank you. Sébastien.
Sébastien Benoit, I am the CTO of InnoCell Development. This is a new company, a young company, and InnoCell wants to participate to the decarbonization of the industry and of the heavy-duty mobility. We develop PEM fuel cell modules, but not only PEM fuel cell modules, we develop also powertrain for heavy-duty mobility, as I said. The main market for us will be ground transportation first, with trucks and construction machines. And the other main important market will be marine boats, and the third one will be stationary. We plan to have PEM fuel cell module going from 300 kilowatts to 3 megawatts. So the solution will be very versatile, and this way we will be able to address different markets.
Thank you. So hydrogen is a bit of a hot topic nowadays. Everywhere we hear about hydrogen, obviously pretty strong here as well, with a few teams taking part using hydrogen. There's been evolution, technologically speaking, although the technology has been in existence for a long, long time. But one of the key evolutions everyone is waiting for is storage. So if you can briefly recap, explain, or before you actually talk about your solution as well, for everyone to understand what's the constraints or the limitations, and to what extent this has actually made the development of the hydrogen society slower, and where you anticipate, where you see the near future. It's for the three of you.
You can.
So, maybe I know that some of you know that our company is a sister company from Energy Observer, the first hydrogen vessels that go all around the world. The boat is sailing now from 5 years, and with hydrogen fuel cells that we develop without any default up to now. Basically, we do not have any storage issue because we are producing our hydrogen on board with an electrolyzing. So basically,
we'll talk about that afterwards.
Okay, sorry.
There's another.
But then just to give you a highlight, in our group, we have a foundation, and you can see live on the web, you have the study by the volume difference in between all the energy that we can have on a boat, like methanol, LNG, liquid hydrogen, hydrogen storage with 350 bars, 700 bars, and also some liquid hydrogen carrier, like a high C-Lab, which we really like. And the idea is that today hydrogen, let's say up to the regulation of now, we are taking 7 times the volume of a diesel. If you go to liquid hydrogen, it's the double of the volume. And comparing to other liquids like LNG and methanol, the methanol is 3 times the volume of diesel. And and the liquefied hydrogen is depending on the quality of the product. But this, I guess I give you the word now.
Yes, there are too many ways to transport hydrogen in the vessels. So, except of course the high pressure, the liquefied hydrogen means cryogenic hydrogen. So you go below 200 degrees Celsius to store the hydrogen itself. Or you can use liquid hydrogen carrier as the one we developed. There are advantages and disadvantages for each. The liquefied hydrogen is very interesting to use because it stores a lot of energy for a small volume and small weight, which is very interesting in a boat. The disadvantages is liquefied hydrogen is quite tricky to manipulate, as it's still a gas, it's a liquid gas, so it is more complicated than LNG, but still it's a proposal, and that's something that could be used in the marine industry. The other one is liquefied hydrogen carriers. So it's really liquid that you can store in standard conditions, and you can use also the same logistic as the one used for conventional fuel. So you can pump it up, you can do whatever you want. You don't need to design or redesign or retrofit any vessels. You can use the same tanks as the one used for fossil fuel. So it's also an advantages. There are two different kinds of liquid hydrogen carriers. The liquid organic hydrogen carriers, so it's fossil fuel derivatives, and they charge the hydrogen, and you need some energy to release the hydrogen from the liquid organic hydrogen carrier. So you need energy to release when needed the hydrogen. And the other one is a non-organic hydrogen carrier. I'm very happy to say it because I'm the only one in the world that developed this. So the company IC Labs is the only one that can say we have a liquid non-organic hydrogen carrier. And the main difference is we don't need energy to release the gas from the liquid carrier. So it's again, it's a difference. I'm pretty sure in the hydrogen industry, all of this technology will have their perfect fit for the vessels industry or for the mobility sector. So again, it's not, I'm not saying my technology or the other one is better than the other. It's really like a mix of different technology, and it will depend on applications.
At Inocel, we are mainly familiar with compressed hydrogen storage at 700 bars mainly. Just to give you some figures, if you want to store 6 kilograms of hydrogen, you will use a storage of close to 100 kilograms. So you have a ratio of 6% only. So it's not a lot, and you can imagine if you want to have 100 kilograms of hydrogen, the size of the size and the volume and the weight of the storage you need. But it's something, from my opinion, compressed storage is something safe, because there have been a lot of experiment and done on the storage, on the compressed storage. So we are mainly familiar with the compressed storage on our side.
We've talked before about the impact or the influence of the automotive world. Obviously, when it comes to storage of hydrogen, is this something where you see the evolution from the automotive, like we're talking about 700 bar storage, getting into the maritime sector, or is it not going to happen because of whatever reasons?
In fact, we were surprised because when we had the first certification on boats, the certificate organization, they dedicated the regulation they developed for the LNG. So the LNG maximum pressure was 400 barrels. So we were limited to 350 barrels for hydrogen storage, like all the industry. But the Japan organization authorized the 700 barrels boat, and then after the European certification authorized the 700 barrels. So now we can design a 700 barrels yacht in Europe, which was not the case 2 years ago. But with my colleague here, yes, let's say gas pressurized hydrogen is something very mature in the industry. It's mainly coming from the automotive because they are looking for increase the power density, like for the batteries, they come from the LiFePO from now to the NMC. That's the same wish about increasing the power efficiency. And I guess one of the key points, and that's one of the message I want to share with you today, as being part of this marine industry, we are key players for the development of the world of this hydrogen ecosystem, because boat will be one of the biggest consumers of hydrogen. We know that the future world will be a mix of energy. Mainly the light transporter will go through electric, and the heavy consumers will go through some other electric conductor, like hydrogen might be a good electrons carrier. And this industry will go through this storage. So basically, today, the gas storage, it is already mature, but we see that it's taking too much volume. And I know that all the architects are struggling with the owner because they do not want to take out some toys or take out some rooms for the guests. They really are concerned about the volume they have on the yacht. So that's why we need also a new solution like a liquid hydrogen or maybe a liquid inorganic or organic carrier to be able to have some retrofit about existing yacht with the same volume that we are already using by battery, tank of diesel, and the engine.
Thank you. Before we get back to the efficiency and the fuel cell and the technology, still on the idea of storage. So you're saying 700 bars, mature, compressed hydrogen, no problem, could be installed on every yacht and it's safe and everything. And yet, there's not there, not yet. I mean, compared to, obviously, batteries are being installed more and more. So what do you see as the limitations for that development beyond the fact that it takes space?
The main one is a supply. I have to say, I'm sure that most of the yacht designer, yacht seller, broker, they already have contact with some owners that want to have a zero-emission boat. It's like a electric vessel. It will be easy for them to sell boats if they have the range and the power and the weight that the owner is request. And for the hydrogen, it's the same. Today we have let's say a commercial pipe over 800 owners that want to have hydrogen vessel, but they cannot pass the order because they have not the supply of hydrogen. So mainly, let's say, the biggest point we see today to help the development of hydrogen boat will be the supply of hydrogen and having a boat able to go to a hydrogen station.
Yeah, it's a refueling station, you want to say. Yeah, I agree. I completely agree. The main problem now today is the refueling station everywhere. It could be for a boat, but it could be for automotive too. You've got the same problem exactly. Today, the price of a station to refuel at 700 bars is more than €1 million. So you can imagine if you have to put stations everywhere in the world, the price for this is very expensive. So this is probably today the main problem.
Okay, we'll get back to these points tomorrow with the hydrogen working roundtable. I want to focus more on the technology side of things. You said 700 bars, no problem, mature, right? What about the complexity of, we'll talk about the complexity of the technology of the fuel cell, but what about the complexity of the integration, something that was mentioned, and then the complexity of the use on board when you have that kind of solution, storage and fuel cells?
So the first one is the supply. So let's say having a hydrogen station. That will be a topic of tomorrow, I guess. So, and the second one is the volume. So we just speak about the storage because today we have yachts which are sort of representative about what the people are used to. But now if they really want to have a solution which is zero emission, but they do not want to make a compromise. They do not want to make a compromise in between the price, which in the yachting industry it's a bit special because some of them are okay to pay the double because they are accepting this and they want to be part of the mood about I have a zero emission boat. But the other one is the volume. So let's say it's taking a lot more volume. I am agree with my colleague and something which is important. When the boat is full, let's say full of diesel and full of hydrogen, the weight is the same. But when you empty the tank of diesel, then your boat is a lot lighter. While in hydrogen, the boat does not save a lot of weight. So that's the biggest difference you have in hydrogen and diesel. But except on that, now the main one is the volume, and the integration is like a hybrid boat. It's, let's say we already have all the knowledge and expertise to integrate such boat.
I think today, if we keep the same volume in the boat, we divide the autonomy by 2 with hydrogen, something like this, okay? So we have to do a compromise. It's not always easy.
Okay, and so what do you think in terms of your technology for storage can help overcome that barrier? And if it does, what's the timeline for it?
Yeah, so maybe a quick intro, more technical intro on the technology itself. To release the hydrogen from our liquid carrier, we just need to mix this liquid carrier, that the one we developed, with water. And we can use seawater. So basically, we can store up to 10%. When we say high pressure is around 7%. Right now, we can propose 10%, and it's still liquid. Then, when it's mixed, you can get rid of the byproduct because it's like a silica. So silica, there is no impact on the environment, so you can get rid of in the sea, sorry. So that's why also we all along you are traveling, the weight will be reduced, which is not the case for high pressure. So that's why we see liquid hydrogen carrier a real future for liquid hydrogen carriers in the marine industry. The main challenge, I would say, is the more you need to store massive volume, or the more you need to store massive amount of energy, meaning massive amount of hydrogen, new technology will need to be developed. High pressure are well adapted to applications where there is no such a big problem for the storage, which is very good for us as liquid hydrogen carrier developers, because it's still a first step. And then for massive applications, for massive high volume applications, then we will need to find alternatives. But to be honest with you, we also need these massive applications that consume a lot of hydrogen for us to be on the market, because we cannot develop this kind of technology without any consumers. And so it's always the same thing with hydrogen. So that's why we need to work closely with people that develop high pressure to let them enter the market. And then the more that we need energy, the more that we need hydrogen, then our technology, liquid hydrogen carriers, will have the perfect fit. And also, something interesting to keep in mind, hydrogen refilling station could be complicated to implement, because sometimes storing a lot of hydrogen in a port, for instance, or close to city centers could be very complicated because of the high pressure regulations, which is quite good, but still it could be complicated. Why? For liquid hydrogen carrier, we are not considered as dangerous good, all of the liquid hydrogen carriers. So that's why it's something very interesting, because you don't need any specific regulatories to store hydrogen in our liquid carrier. It's the same regulations as the one used for conventional fuel. So then we will be able to develop a network of hydrogen refilling stations without any specific investment and specific capex. That's, again, the big difference. But I'm not saying that liquid hydrogen carrier will be the only solution. I'm just saying that for massive applications where there is a huge need to store and transport large amount of hydrogen, liquid hydrogen carrier will make sense. For the other applications, it doesn't make any sense at all.
Okay, thank you. Let's get back to the technology, the fuel cell technology itself. We were talking about batteries earlier, where we know we have a very high efficiency. What's the evolution you anticipate in terms of efficiency of fuel cells? I mean, obviously there's been a lot of development and progress made. Can you see things getting better on that front? We know that it's much better than an ICE anyway, but can you see any, I would say, not a revolution, but at least an evolution that will justify also the faster shift to hydrogen?
Just to give you an idea of the evolution of the performance in the last 20 years, one development has been done by Peugeot in 2005, and the power density of the fuel cell, of the stack fuel cell, was at this time 2 kilowatt per liter. Now, with our technology, we have multiplied by more than 2 this power density. So now the power density, the state of the art, is between 4 and 5 kilowatt per liter, or a little bit more. It depends on what we consider in the stack. So the performance is better and better. It's the same thing for the efficiency, because there are many institutes and many companies working on the development of MEAs. The MEA is the membrane electrode assembly. This is the electrochemical earth of the fuel cell. It's where the reaction occurs, and the performance of the MEA has increased a lot in the last 20 years. And now the efficiency of a stack only is close to 60%. And if we consider the stack in the module or in the system, it is close to 50%. So if we compare this to a diesel engine, for example, the diesel engine has an efficiency of 35%, something like this. So the engine, 35%. So it's much better, but it's not enough. We need to work again and to work to improve the efficiency. And one of the main concerns of InnoCell is to improve the efficiency of the system. and we have developed a system with less ancillaries so that we've got a better efficiency of the system.
At EODEV, we select basically the Toyota fuel cell technology compared to the other automotive cars. They were continuing investing in hydrogen. So today, everyone knows that that's the best technology in the world. The average efficiency, so basically it's like in the fuel cell technology, you have to compare apple with apple. So basically there is the power, the brute power coming out of the fuel cell, and you have the overall power, let's say the net power that you can use when you consider all the consumption of the auxiliaries. So basically today and that's the first one. And the second one is you can have the efficiency at the beginning of life, and you can consider the efficiency at the end of life. It is very easy to have a 65% efficiency at the beginning of life, but then if you have the end of the life and the end of life, it's very short term, then you have 30% efficiency. The total cost of ownership for the life case and the use case of the boat is not anymore a good one. So basically, that's the IP that we develop, and today we are working on a solution that we can offer. This year, the products that we are delivering are 13,000 hours. Next year, we are working on 18,000 hours, and we are still working to be able to achieve 30 to 50,000 hours lifetime. And the efficiency today, let's say the average efficiency is 50% for the whole lifetime, which is today the best on the market. And on the evolution on any generation, we will say win, let's say, 5% efficiency at any evolution. So the coming evolution will be 55% efficiency for the overall lifetime. And let's say in 2027, you will have on the market a 60% efficiency for 30,000 hours. And the good point, because on a fuel cell, you do not have any movement part. So let's say you have a lot less maintenance, plus the lifetime is a lot longer. Now we can also offer a 50% lifetime warranty. So if the lifetime is 30,000 hours, we are offering a warranty at 15,000 hours, which is 10 times the warranties that you are today on the diesel. And that will make a huge difference. And thanks to that, we have now also a new banking solution, which are leasing the solution up to 10 years with a 10% residual value. So the monthly cost of the solution is cheaper than a diesel solution.
Good that you mentioned that, because that was my next question. We know it's expensive technology. So how do you see the evolution, not from a technological point of view, but from a cost point of view in the perspective of adoption? I mean, you did mention that the lifetime makes it relevant because something that people may not think about, but it's still very costly. So what's the ratio there when you compare with other solutions, for example?
Yeah, that's a good question, because we can see two curves. One is the overall efficiency, so the increase of the performance. Basically, it's a logarithmic curve. So basically, when we are already on the top of the assumption, and at the price point of view, we are still the price is still reducing, but it will not reduce that much. Just for example, you know that just the crisis we just had all together with the COVID, and after the war in Ukraine, and now the semiconductors, let's say, no, it's another war, but supply warming, then we do not see that the price will reduce a lot because of this, let's say, general increase of price for the whole life in the world. So basically, we see that maybe the price can go down from 5 to 10% in the coming 5 years, but not that much. The big thing is that due to the evolution of the power and the overall efficiency, it will be more and more competitive to diesel. But something which is very important as a yacht owner or as a yacht broker, and we are all part of this industry, we need to highlight something, that when we are comparing a hydrogen solution with green hydrogen, we are not polluting. And today, if we are using a diesel solution, we do not pay for the pollutants that we are exiting. And I really invite all of you to share the common vision and the common idea that it's not our role to give to the next generation to pay for our life. And we have to pay for that. It's coming because there is many CO2 tax that will come, unfortunately, to ban the pollution. But I would rather give a good point that people which are the first of the group going into a zero-emission solution. And I guess if we consider that, just with 60 euro per tons of CO2, hydrogen today is, on average case, 15% cheaper than a diesel solution.
Thank you.
If I may add something about that, it's also we need to talk about green hydrogen. Green hydrogen, as Jeremy say, is very important for the hydrogen industry. You have to keep in mind that green hydrogen is produced from renewable energy, so it's really a way to store and transport renewable energy where it could be produced at the lowest cost. So hydrogen is a real carrier in the energy transition. So it has to be considered as one of the key elements in the energy transition, because we need and we have to store this massive amount of energy, green energy, that will be produced all over the stages of green hydrogen produced from renewable energy. And thanks to that, we can decarbonize all the market, we can decarbonize a lot of applications, thanks to the capacity of renewable energy and the green hydrogen.
Okay, thank you for all the messages. I would like to get back to the technology and the cost associated with it. Your solution, if you were to compare, okay, maybe it's not available right now, but how do you situate it in terms of cost or for like distribution infrastructure and everything compared to the existing network of solutions that is very expensive? I mean, how do you see that evolution?
Again, it will be, we can have a real reduction in costs. The more you will consume hydrogen, the more we will be able to reduce these costs. We are developing a technology, again, to store and transport massive amount of hydrogen. So it will be an industrialized technology. The more we will be able to industrialize, the cost will be the cost will be reduced. In terms of costs, just to give you an overview. When we store in a compressed gas around 200 bars or 300 bars, for the same volume, liquid hydrogen carriers can divide it by 7. So with one tank, we can store up to 7 times more than compressed gas. So thanks to that, we can reduce drastically the cost of storing and transporting. Then I wouldn't say that of course, we are 30%, 40%, up to 50% cost reduction compared to other technology like high pressure or ammonia, which is for me a nightmare for the marine industry. But anyway, so I'm just talking about the cost itself. So the costs, we can reduce the cost because we use the same infrastructure as the one used for conventional fuel. But we can also reduce the cost because we will be able to store and transport the hydrogen produced where the renewable energy are at the lowest cost. So where the hydrogen, the green hydrogen will be produced around €1, we can transport then the hydrogen using the same logistic as the one used for conventional fuel, which is very not expensive at all. And at the end, we will be able to deliver hydrogen around €2 or €3 per kilogram of hydrogen, which is really, really, really a very interesting cost for all the kind of application. Of course, we can still improve it, but it's a very competitive one.
Yeah, just to give you let's say, it's very good to go in the detailed numbers. So today, to give you some points, if you have a gas hydrogen, so logistic price of this logistic of hydrogen is it between €1 to €3 per kilo. Where you compare, let's say, the ADEME, so the French administration about the energy transition, says that the target price to have the same price of hydrogen compared to diesel is €9 per kilo. If you add on €9, €3 of logistic, it became a lot more expensive. Then if we consider, let's say, plus €1 for the logistic, €10 per kilo. Today, with €10 per kilo on our solution, the average price of a kilowatt hours is around €1 per kilowatt hours, which is, let's say, 20% more expensive than the diesel, with the diesel at €1.9 the liter of diesel. If the price of diesel is €2.5, then it is 20% cheaper. So that's why I just told you that today our solutions are already competitive compared to diesel. If now we want, that's the total cost of ownership. If you now focus on the CapEx point of view, for the marine application, our range extender, which is 80 kilowatt hours net solution, the average price, let's say public price, is €150,000, which is a double of a standard diesel generator. So basically, the in-front price is a double of the one, but because the efficiency is higher and we have a lot less maintenance, and you can have it for 10 years. After 10 years, the total cost of ownership is 10% cheaper than a diesel solution.
Thank you, Sebastian.
Yeah, just one point. If you compare this with a standard car, with 1 kilogram of hydrogen in a standard car, you may drive for 100 kilometers. Okay, so 1 kilograms of hydrogen, 100 kilometers, and you see the price now is around 10 euros for 1 kilograms. If you compare with your diesel or gasoline car, you can see the difference. In the future, it will be probably between 2 and 3 euro per kilogram. So you can imagine that you may drive 100 kilometers with only 3 euros.
And there is a gentleman here a lot more advanced for me on the hydrogen station in France, but just to give you an idea, I know that there is more than 200 projects of hydrogen station in France. It's a number that I just discovered last week. I was not expecting that much, but it will be an example about hydrogen is coming. It's coming in France, it's coming worldwide. We have more than 200 already in Germany and also in Italy and Spain. So because a huge part of the, let's say, yachting industry is here in south of France, I'm really looking forward to see people that are investing in hydrogen station for boats.
Okay, thank you. Let's get back to the technology side, because this is the hydrogen roundtable. The working group is tomorrow, right? So we talked before when it comes to the batteries and the other technologies, especially like solar panels, about integration and the complexity of the technology. Even if it's mature technologies, you said storage is mature. Okay, it takes space, but it's mature. The fuel cell technology obviously is mature as well. To what extent these technologies, which are high-tech, are limited in their development or implementation because of the difficulty or the complexity of integration, especially when it comes to the marine world? Similarly, like what we said before with batteries and solar panels? Or?
It is true that today, if we really want to have a look about, let's say, the RACI matrix about who is responsible of what in an integration of boats, we can see that there is not a lot of people expert in the hydrogen, let's say high pressure hydrogen, or the hydrogen in between the tank and the tube and the pipe to go up to the fuel cell. After the fuel cell, when it's electricity, then there is many people that are already used to work with electric boats, batteries, and they are very already famous and well known. But on the hydrogen expertise, today, all the boats and all the projects that we are doing, we are following our client and we share with them the expertise and we do the integration ourselves for this hydrogen, because today there is a need about having a hydrogen expert for this, let's say, high pressure or liquid hydrogen carrying by transforming this hydrogen carrying solution into gas and then sent to the fuel cell. I know that there is many other boats which are working with ethanol and a vapor reformer on board to create hydrogen and use the hydrogen. But so this expertise, I guess, it's a bit missing in the yachting industry at the moment. But all the other, let's say, installing a fuel cell is like installing a normal genset, and out of the fuel cell you have the electricity and the water, which is a standard one, and all the experts are already here.
I see another limit to the integration. I think the standardization of the module is not done today. All the different manufacturers have different modules, but for the interface between the modules and the boat or the car or what you want, you don't have any standard. And today it's probably a big problem. There are some projects going on to standardize the different interface you have on the module and to be able to have one standard. This way it will be probably much easier to integrate the modules in the applications.
But when it comes to usage, I mean, you imagine you have the fuel cell, you have the IC-Lab solution for storage on board, the batteries. How complex does it seem to be, technologically speaking, or for the captain or the engineer? Because we can feel that there could be reluctance about adoption of solutions, not because the technology is not mature, but because people don't know about it and are worried or afraid of using it. How do you see that evolution?
Let's say that everyone was scared about hydrogen because everyone was scared about the gas. It was an explosion and dangerous gas. That was one of the points. I guess most of the people are still scared about it, as I am with my people when they made a demonstration. Like here in Monaco, we just want they are proper wear well and they are not smoking and all this because that's just normal. And I think that we just proved in the last 2 years, but maybe I can invite some of you to see that hydrogen, it's a gas. It is for sure a dangerous gas because the ignition point is just 60 degrees. But this ignition point can happen only if the stoichiometric exchange between hydrogen and oxygen is you have 30% of hydrogen between a volume of air. And you can consider that the weight of hydrogen into the air, it's like if you are in the water and you have a bubble of air. So, you know, if you dive in the water and you have some air coming out of you, you can see the speed of the water, as the air is going out of the water. Basically, oxygen, it is exactly the same in the air. So if I have some hydrogen here and open it, you can see the bubble is going here up at the same speed. So it's something that we need all to anticipate, to integrate, but le pouvoir de déflagration.
Explosiveness.
Yes, deflagration, explosion. So the power of the explosion is 8 times lower than the butane or propane. Let's say the most dangerous thing is if you light a fire of hydrogen, you cannot see it. So that's dangerous. And when we made all the risk assessment, one of the biggest points of the risk was that if you light a hydrogen fire, there is no image out of it, and also there is no reflection. Thermal reflection. So basically, you can be 10 centimeters for the fire, you do not feel the heat. So these are the two, let's say, risky point after it. But because it is, from now, high pressure storage, it's very easy to see if there is a leak. There is many detectors which are very efficient, and as soon as you have less than 1% of hydrogen in the room, it can start. You already have some cameras that you can have in your engine room that detect if there is hydrogen, the leak, the amount and the quantity of hydrogen which is coming out of the hydrogen pipe. So all these solutions are very, let's say, already existing. And if you consider that it does not smell, but this gas is less dangerous than the butane and propane, I'm sure you all love to do some barbecue with your friend. Some of you have now some butane and propane and you are not scared turning on the barbecue. So it's a sort of being used to use hydrogen. And that was one of the points that I really want to explain, because this risk thing was a bit too bad. And I can invite you to try to test our generator. You can start it, stop it, disassemble it, and you will see it's very easy going.
Yeah, and I would say about all these safety issues. I don't like to use safety issues because hydrogen now, we know how to manipulate hydrogen, and there are a lot of, as you said, equipment to monitor the hydrogen itself. But something very interesting, again, sorry, I'm doing some promotion about our technology, but like with the liquid hydrogen carrier, we will not need any specific equipment, as the hydrogen itself will be produced and directly consumed into the fuel cell. So there won't be any equipment related to the storage, to hydrogen storage. So that's something that will for sure facilitate the integration of this kind of hydrogen technology into the marine industry.
What's your timeline?
That's a good question. What's the timeline? We inaugurate last month the first plant that start producing the liquid carrier from green electricity and green hydrogen. It's based in Aix-en-Provence, so if you want to visit, you are very welcome. And we need now to work on the scaling up of this technology, industrial scale. So in 3 years, we will be able to start delivering tons of hydrogen, which is not quite enough compared to the market, but as it's an industrial technology, it takes time to industrialize the technology itself. So we will be able to deliver massive amount of hydrogen in 5 years. So that's the idea.
Okay, thank you. I'm sure there's plenty of questions from the floor, and we'll try and keep it short. You'll be able to have a conversation because we will have a break, a short one, but we'll have a break. Yes, there is a question there, lady here.
Are there any regulations that translate directly into spurring innovation and getting costs down? You had mentioned banning pollution as a kind of a great example. Are there any other regulations that you guys are kind of keen on that can get passed to help spur the industry?
Yes and no. In fact, it's the opposite. The regulation that we just are facing today with hydrogen, it's security of the security of the security. So the price is increasing to integrate in boats. But we just faced that DNVGL and Bureau Veritas. That was a bit of, excuse me the word, a bit of not stupid, but that it was more dangerous to add some safety than not having it. But in the other way, you're right, the Innova boat was an idea that came from this lady, Chloé Zayed, because she was facing the regulation that she cannot sail in south of France, like in le Parc National des Calanques, close to Marseille, because they banned the diesel. So the regulation was a need in order to create a zero-emission boat, and that area was 10 miles away from the harbor, and because they want to send some tourists and some fishing boats there, they have to go at least 4 times a day. They were not able to do that with an electric boat, and they need 6 to 8 hours to recharge the electric boats. So the electric boat was not an option for going in this place. And I have to say that most of the professional usage, they are interested in hydrogen, especially because of the same case. They need a huge amount of usage hours, working hours per day, and they need a short time recharge. And this is the need of the hydrogen. It's lighter than the battery, and you can recharge it as fast as a diesel with zero emission. So basically, the regulation, in a way, it's yes. In the other way, it's no. If it's a professional usage, you can, and we are working on having some credit, carbon credit. So basically, when you buy a solution, you receive some grants, but it's not already working in all the countries. We are struggling to finalize that in France and in Europe. But I hope that before the end of the year, we will be able to give a sort of money back to our first customers.
We'll discuss further this afternoon, these aspects.
Maybe just about the regulations around the liquid hydrogen itself. As it's a new molecule, there is no regulation at all. So it is as complicated as the one for hydrogen, for sure. We hope that it will accelerate. But as Europe-like regulations, bringing a new technology, bringing a new molecule on the market, even if it's something very safe, they like spending time on being experts. So we will need to spend time with them and discuss that everything is going well. But it's on good pathway because the molecule that we developed is close to silicon hydride, so it's close to silicon industry, so it already exists. So we should be able to bring the technology very fast because of these already existing regulations.
Okay, another question? Quick one? Okay, great. Thank you. So just to sum up, the technology is mature, everything is working well, regulations can be a problem, complexity is not so complex, and so distribution and refueling is the key issue at the moment. Thank you, gentlemen. We take a short break, 15 minutes max. Please be back within 15 minutes, and then we will address the idea of producing your own energy on board, the idea of autonomy, being autonomous in energy, which is the next potential step. Thank you. Ladies and gentlemen, outside, could you please come back in so we can get started for the last part of our morning session? If you do want to have a bit of time to have lunch afterwards, I invite you to come back as swiftly as possible. Please make your way back in. Otherwise, you won't have much time for lunch.
Non, mais par contre, il faut qu'on dise, c'est pour ça. C'est dans 1 heure. Dans 45 minutes.
Please, everyone outside, need help? Can you make your way back in? We're about to start with the last session of the morning, where we've got two short... they can't hear. So anyone who's close to the door, try and help bring the people back in. Otherwise, you won't have lunch. If you want to have lunch, please make your way back in as soon as possible, because we have to get back to the conference day at 1:30. And you have plenty of time to have a conversation during lunch. Or no lunch. Do we know if we've got Nicolas Lap? Is connected? Okay, great. So the next panel, I would like to, we've got 1, 2, 3, 4, yeah. I would like to welcome on stage already, please, if you can, from Alva Yachts, Mr. Denis Deroos, who's the commercial director. From Zen Yachts, Julien Melot, the designer of the Zen 50. From Rossi Navi, Federico Rossi, who's the COO. And from Silent Yachts, Stefan Kress, who's the Chief Innovation Officer. And joining us online, we've got Nicolas Lap, who's the Chief Operating Officer of Sunreef Yachts. The idea of this panel is basically to talk about the production of carbon-free energy on board. And the idea behind that is we know that is the ultimate goal of most boats would be to be able to be totally autonomous. So when we divided the sequence into two sessions, one is about mostly solar energy, and the other one will be about electrolysis and hydrogen production, because these are obviously the two core elements behind wind, to be able to have your energy on board and not rely on carbon fossil fuel. So this panel is more about sharing the experience and explaining to us the difficulties, the benefits obviously, but also the difficulties and the evolution of being able to be totally autonomous with energy on board. So we've got a large panel, and we'll try and keep it short as well. And I would like to have then Mr. Denis Deroos to get started with their approach to the use of solar panels and what achievements it means, what difficulties, what constraints, and how they try and optimize their solution. Mr. Deroos. You need to turn it on. Yes, it's on. Test? No? Okay, use mine.
Okay. Good afternoon, everybody. Thank you for having us here. I really appreciate the opportunity. My name is Dennis de Roos. I'm the commercial director of Alva Yachts. As you can see, we have a beautiful Ocean Eco 90 here on display. Alva Yachts started as a business in 2013, and 2019 we had the idea of really starting to develop a range of solar electric yachts. And we've now been developing the product line. We've been selling actively. We now have a range of yachts, kind of starting at 50 foot, then 60, 78, 90, and we keep on developing on new product ideas as well. All our yachts are designed from the ground up to be solar electric drive, and we have diesel generators as range extenders to give the yachts a really good range. And we start with a 50-foot yacht that's a monohull that has about 8 kilowatts of solar panels on the roof, to this 90 model you can see here, which has about 40 kilowatts of solar panels on there, so really a significant amount. And we are fully focused on this market and really excited to be part of this industry and innovate as much as we can.
Thank you. Can you tell us, and then we'll get to the other panelists, can you tell us how do you achieve, the type of performance of being as solar efficient as possible, or in terms of how much power you need and how you optimize your solution?
Yes. So the important thing is that all our yachts are designed from ground up to be solar electric. And so the way the hull is shaped and designed is for maximum efficiency. Our yachts are really focused on long range and be like an explorer type vessel. So we have more solar power on the yacht than we need to actually propel the yacht. So we have an ability to run an Alva yacht solely on solar power only at a relatively low speed. But the possibility, of course, is there to do that. And then the faster you go, then the range extender would kick in. And then that would give us additional speed and additional range as well. And in terms of the challenges that we face, I guess, is we constantly look for the best, highest quality materials that we can use. We're a manufacturer of yachts. We don't manufacture electric motors or batteries, so we source these from third parties, and we really go into the market to find the very best quality that we can find to create a very good value proposition for the customer. I think the clever bit that we do in-house is that we have an integration system called Alva Connect, where we make all these different systems talk to each other and be as efficient as possible. And also this allows us, for example, to do over-the-air updates and to monitor yacht's performance. Doesn't matter where it is in the world. So this gives us really some added benefit to having a solar electric Alva yacht.
What's the key then to the being solar electric? Because we know the sun doesn't shine all the time. So how do you manage that situation? Like the amount of solar panels, you said you've got more than what you need, but how many panels or how much power do you need? Because we know in the yachting world, usually you need a lot of power.
Yeah, no, indeed. We've done the calculation that the roofs are designed to house enough solar panels on there that it, as long as the sun is shining, of course, that you can use the solar energy, even have a hotel load which is functioning as well without having to use a generator on board. The challenge, of course, is to make sure you have the solar panels are positioned in such a way you're going to maximize the effect of getting that power from the sunshine, and there's not any kind of dead spots and things like that. So we're very much from a top-down approach, whereby we're trying to maximize that.
Okay, thank you. May we have Nicolas Lapp from Sunreef? Are you here? Yes.
Yes. Hello.
Great to see you.
Can you hear me? It's okay.
We can hear you. Yes.
Okay. Perfect.
Okay. So the panel, the floor is for you.
Okay, hello, I'm Nicolas Lapp from Sunreef Yacht. We are building catamarans since over 20 years. And Sunreef, it's of course a family company, and we are very keen of innovation in the company since the very beginning. And during the last few years, I think it was like 4 years ago, we started to make the concept of the eco yacht and to drive the Sunreef to the future. And we end up with the problematic of the solar panel, like I think everybody, and we've decided to build our own solar panel due to the fact that we wanted, in fact, to optimize the space, and we wanted to keep the shape of the boat relatively similar to what we had in the past. So I think that we are one of the only shipyard building the own solar panel. We are using one of the best cells on the market. We have an efficiency of up to 25%. And we integrated a lot of other system. So yeah, I don't know if you want me to go ahead, or if you want to ask some question, I can go further.
Up to you. The key thing I retained from what you just said is efficiency of 25%. So, I mean, this is something that seems pretty good. To what extent it gives you enough power to be able to be autonomous, relying on your solar power?
Yeah, so like it was said before, we want to optimize the amount of solar panels. So actually on the 80 foot, we were able to have around 40 kilowatt peak of solar panel. And I think the most important for the future is of course the production, but as well the consumption, the hotel load. So we were working a lot on the hotel load side to optimize, because there is a lot of equipment that are not very efficient, and we are working very hard to get the efficiency in the best range as possible. We are talking about air conditioning, we are talking about propulsion, we are talking about all of the house equipment in general. So that's why we decided to go for 600 volt system. We try to get as many equipment as possible on 600 volts. So for example, we are one of the first company having the air conditioning in 600 volt. We have the boat thruster in 600 volt. We have the hot water boiler in 600 volt. And we have the propulsion, of course, in 600 volt. So we are trying, thanks to an HME and automation that we do in-house, we are trying to make all of the things as efficient as possible. So you were asking before as well for the intermittence of the sun. Of course, we have a big battery bank helping to catch the time where there is no sun. So that's the things that will be in between, or for the night, for example. So we are able on our boat to run the air conditioning for the full night without any problem. So that's a bit the direction. And to come back to the solar panel, the technology that we've developed, we have the solar panel, which has practically, or I think, the lightest in the world. So actually to generate around 35, 40 kilowatt peak, the solar panel weight more or less 340 to 360 kilogram, which is less than a 40 kilowatt, for example, generator, which would weigh 400 kilowatt for similar power production, more or less, yeah.
Okay, thank you. So your approach is to say the strategy should be obviously consumption reduction from the hotel load especially, as many solar panels as you can, and the combination of the two with a strong battery bank. How much battery power you've got on board?
It depends, but let's say on 80 feet, and on 80 feet we have between 440 kilowatt to 990 on the power boat. So that's the range more or less. I just wanted to add as well that that at Sunreef we are trying to build luxury boat, and we don't want too much to have compromise for the customer side. So if the customer is willing to run the aircon or to have a proper hotel comfort, our goal is to reach the comfort of the customer at the end. Because of course it's easy to say, okay, to say to the customer, don't use the aircon, don't use the cooking plate, don't use that. But at the end, the comfort is something that customer is looking for this kind of boat and this price they are paying for. So we are trying to not too much compromise the comfort on board.
Okay, thank you. One last question for me. In percentage-wise, how much power is brought into the yacht from the solar side of your energy source, basically?
Yeah, this is something that it's, let's say, complicated to answer because all will depend the operation profile. We have analyzed a bit the use of the boat, and most often for a charter boat or even for our own boat, the boat is not moving very often. I mean, when there is a charter in place, the boat is moving 30 minutes, 1 hour a day, and then the boat can be fully autonomous. That means that he can run fully on the battery. But of course, the question is more for the long voyage. For the long voyage, I'm still convinced that the solution is the sail. That's why we are building as well sailing boat, because when you're crossing the Atlantic or making long passage, I mean, the sail are the best and the cheaper way to go for a long distance. And on the top of that, when you're using sail, you can hydrogenerate some, thanks to the propeller, you can produce some energy through the propeller system and the hydrogeneration. So yeah, that's what would be. But of course, the power boat can still go across the Atlantic. But like said, my previous speaker, we need the range extender in this case, yeah, to get faster and to be able to cross the Atlantic, or to go very slow, making some compromise.
Okay, so compromise would be on speed then. We'll get back to that later with the naval architects and shipyards this afternoon. Slightly off the technology side, because you're an established yard with many customers around the world. What do you see in terms of the evolution from the client requests for the eco solutions, for the solar panel solutions on board your catamarans, and what's the trend? I mean, how do you foresee that trend? Is it something that's really picking up, or is it also like what you said about sailing coming back in the picture? I mean, what's your perception on that from a market perspective?
Yeah, no, the growth is huge. We have today over 20 boats which are sold fully eco, and even the boats that are not fully eco, I mean, the customer which still used to purchase classic boat, they are adding some solar panel and they are adding the big battery bank, for example, to be able to use the genset less often. For example, to get the air conditioning during the night without the genset, and then there is a big saving, because if the genset is not running 24/24, of course, we have a big saving. On the EcoBoat, the genset, just for information, is 600 volt as well, and we are working on DC as well to avoid loss of efficiency. But we believe at Sunreef that in the few years, and it's rather getting faster than we thought, we will have only EcoBoat being sold. So that's just right now maybe a question of still price delta between those two solutions. And we are working already on hydrogen boats, which will be ready in 1.5 years.
Okay, thank you. Thank you very much. And we'll get to the next panelist, Julien Melot from Zen 50, who's the designer of the Zen 50. Your view on these issues of producing solar and using solar energy to power the boat. Thank you.
Yeah, sure. Thank you. I've built a few fully solar-powered boats. That means that they not carry any fossil fuel on board. So I speak a little bit of experience in terms of usage of them, and that's what has led me to design the Zen 50. So I fully agree with everything that's been said. So the boat has to be designed from the ground up to be solar powered. And basically what we have to do is, on the one hand, minimize the hydrodynamic drag, as well as hotel loads, obviously. And on the other, maximize the energy you can harvest. So sailing on a solar boat, on a solar catamaran, when it's pure solar, so when you're not using your diesel as a range extender and to increase the speed, it's great if you're a geek, and it's amazing for the first weeks because you realize, wow, I'm sailing from the solar power. It's kind of magical, and then you see the figures on the screen, etc., and you start to play with your speed to be exactly at the same power as you receive from the panels. You manage your speed properly so that you can sail overnight and still have energy to move in the morning. But to be honest, after some time it gets boring, because it's like being on a powerboat at the speed of a sailboat. So what do? Well, either you turn on your genset, which was not an option on my boat, or maybe you think of adding a sail. But people who come to this market are not sailmen at heart. That's been said before. And so a normal sail would not have worked, also because of the stays, etc., so the complexity of the rigging. So basically, on the Zen 50, this is the first leisure boat that will be equipped with a wing sail. It's been extensively talked about by the gentleman from VPLP, so this is their sail, and it's in fact the same wing sail as is equipped on the Energy Observer. A little bit tailored for yachting, so a more user-friendly HMI and these kind of things, but essentially it's the same technology. And that, I think, is the holy grail in terms of energy self-sufficiency, because the boat itself she's very light, 17 tons, she's full carbon, using core sail, so this is the scantlings of a offshore racing multi-hull, basically. Extremely light, so you don't have to move a lot of water. The hulls are displacement hulls, which at solar-only speeds is the only regime that makes sense. Like, you're talking about 4 or 5 knots round the clock if you do your math well. You can't go with semi-displacement at that kind of speed. It would create a lot of turbulences at the transom, so very smooth sailing, racing sailing yacht-like hulls. And then a massive solar roof. So we have 17 kilowatts of solar peak, so a ratio 1-to-1 in terms of displacement solar power. So 17 kilowatts, 17 tons. And then on top of that, you stick a wing sail, which is fully automated. The people on board don't have to care about anything. It's all done by the computer. And the great thing is that to hoist it is just pressing a button, it goes up, you let the computer do the job. If you compare that with traditional sailing catamarans, people, if we are really truly honest, they only sail 30 to 40% of the time when you charter. The rest of the time the sails are down, there's either not enough wind or too much wind and people are scared. So this is great, like per se, it's amazing, and it's going to be a revolution in the leisure boat industry, because you don't have to care. You just press a button, you're off the marina, and let the computer do the job. And then the rest, of course, it's all electric, so you can effectively have a motor sailor. You'll always have a small contribution from the solar into the motors, plus the wing sail, and that allows us, we've done the calculations with VPLP, to cross the Atlantic at between 7 and 10 knots on a boat that has massive volumes and that does not carry a droplet of diesel. So that's been our approach.
Thank you. It brings back to sailing as being part of the yachting world and needs to take its space. Quick question, how much of the solar surface or how much of the power on board is actually provided by solar only? Because obviously now you're adding sails, so that helps. But what's the approach, in the sense that is like your solar power will cover 50% of your power requirements, or
So the answer is again the same, it depends on the speed. It's essentially designed as a solar boat, a very light and very powerful solar boat. So we also commercialize it without the wing sail. So if you're okay with doing 4 to 5 knots continuous, you don't need the wing sail. The solar provides 100%. There is no diesel backup. If you want to go faster, having a bit more fun, and also be safer, because that's another problem with the solar boats, is when you do an ocean passage and you want to escape from a front that's approaching behind you, you have no way. Or you have to have a powerful diesel genset, right? But with the wing sail, obviously, as the wind will pick up, you'll be able to sail away. So, but essentially, you can sail without the wing sail.
Okay, thank you. I'd like to have Federico talk about Ronde Cinevi's new projects, because we've seen here that it's all about catamarans, and here we're looking at the possibility on a much bigger, I would say, boat. So lightness might be a difficulty. So what's your take on that, and how do you approach that?
Yeah, okay, hello. Rossinavi is a full custom-made shipyard. We build boat that is a general, is a motor yacht from 40 meter to 70. It's 1 year that we started to development this kind of boats, and then we are arrived to finish, to put under construction this 43 meters, 499, the super yacht categories, that is hybrid, electric hybrid, we ask it. In effect, there is many different sources to create energy on board. The solar panel is not the majority. If we consider this vessel solar, we need to consider this boat when he's in hibernation mode, where the boat is stopped in the marina in the winter time, where the produce of the energy by the solar panel is 130% more than it needs. And it is honestly, is an operation like navigation mode, because this kind of vessel stays stopped on the marina for the 50% of the time. At the moment, it's complicated to imagine a new generation boat. It's, for us, it's the first steps. And the protagonist of this boat is the artificial intelligence. And if we consider, for example, the solar panel for the regular navigation is maybe the 10% of the power producer on board only. But thanks to a megawatt and a half of batteries, we can consider this boat 100% electric in daily use. And we are the multi-day trip mode configuration, where the vessel is 90% of the time in electric mode and 10% with supported by diesel generator. And for us, it is a very important goal, because we don't want at the moment to think this vessel like super green boats, or I don't know, some vessel that the people must recognize solar panel on board or other things. It's experience. We would like to give our client the possibility to have experience for navigation in electric mode. And it is very important to can put in the market this kind of boats. And the result, we have not so much experience for catamaran categories, for example, is the first one in the motor yacht configuration. But we can observe that after 3 months, 3 months later of the promotion of this boat, we sold, we put under construction. It is a good result.
Well done, thank you. So what I understand from your approach, and I can see 2 different approaches here between the various designers and builders, is you can use solar power, especially when you think about it in the super yacht industry, where most of the yachts are not used that much, as an alternative source to actually power your batteries and store your energy on the batteries, because the boat is not used so much. Whereas the other approach is to say we build a boat, a yacht, a catamaran, especially on the smaller segment, where the boat is going to be used massively. We talked about charter boats especially. So these are 2 different approaches.
It is a different approach, because consider, I can compare with the monohull, okay? It is a catamaran, is a good efficiency for the hull. We can consider to have a lot of space for solar panel, but is only 10% of the power producer. For crossing Atlantic is a little bit more because the configuration, the vessel, there is the intelligence artificial that put the vessel in the cross mode. And then we can do with the 80% of the time in electric mode, 20% with the diesel supported. In this configuration, the solar panel is maybe 18% of support, but it's not sufficient. But it is on a step. We can consider maybe the catamaran versus monohull, 20-25% increase of efficiency. The solar panel is other 10. And we can save power on board for the hotel. We can manage everything very well, and you will save other 10%. And just is a good steps to can think for really a new generation boat.
Okay, thank you. And now I'd like Stefan from Silent Yachts to tell us about their approach to the solar-powered yachting.
So thank you for having us. So from Silent Yachts, we've been actually very early in the game, and we've been producing solar catamarans for 15 years now. So what you see here is actually the 60-footer. It's the 4th generation of solar electric catamarans. At the moment, we produce boats in the range of 60, 80, and 120 feet. The larger ones that you could think of more like explorer-type catamarans. They have around, since we talked about 80-footers mostly, our 80-footer has around 26 kilowatt peak. And I think what's a critical issue, which we also learned the hard way, is that when you have solar panels, you should, under all circumstances, avoid partial shading, because partial shading will actually kill your output even to 2% of the nominal output. So you have to be really careful how you wire up and how you actually handle partial shading. I mean, we're trying to avoid it, as you can see, like on the roof structure. We try to get away with like all of the antennas that you might have in place. And I think that's critically important for any solar boat currently. There are interesting developments that we've seen, but just maybe as an advice to everyone out there, there are exciting developments, but with the current solar panels, avoid partial shading. Maybe some of the specs, we have 26 kilowatt peak on the 80-footer, around, well, the customers can choose, but let's say most choose for 500 kilowatt hours battery capacity at 700 volts. We have peak powers of around 700 kilowatts, which gives you the top speed that some people want, but which are, from an engineering point of view, don't make much sense, but it's mostly our sales department loves it, so that's why we're building it like that. Yeah, and happy to contribute to this discussion.
Thank you. So given your experience, how do you see the trend from the customer's perspective about taking up solar-powered catamarans?
Well, it has been exciting, and as I said, we've been early to the game, and usually if you're early to the game, you're actually failing, but because you're like, the market is not there yet. Like 15 years ago, also the proposition was not as exciting because panels were 10 times the price. I imagine batteries were like 3 to 5 times the price. So it was not, based on an economic point of view, it was not an interesting proposition. That completely changed. I'm actually convinced even now that under the current circumstances that solar, even when stored in batteries, is the cheapest form of energy that you can have on a boat. In fact, we believe it's already 2 to 3 times cheaper than diesel. So the economic proposition is now there. It wasn't necessarily there 10, 15 years ago, but the economic case is there. And that's what customers are seeing. So in the last, let's say, 5 years, demand has been picking up enormously. So whereas maybe like in the previous, let's say in the previous, like until like 5 years ago, maybe 10 boats were sold. We're already looking at 40, 50 boats sold in like the last, let's say, 2 to 3 years. So it's really like enormously picking up. And even though there is a slowdown, maybe currently in the yachting industry overall, we're actually not seeing that for solar electric catamarans. So this is positive, I think, for all of us. The market is growing, and I think the market is big enough for all of us. So.
Thank you. Was actually my next question was about the cost, associated with developing these yachts and the perception of those costs going down. So markets boom. Well, I wouldn't say booming, but it's expanding. What are then the barriers in a way, or the limitations? Obviously, the technology is not a limitation. Even though there may be some further improvement that will remain minor. We talked earlier about integration being a complexity, but not for the user, not so much for the user, more for the integrator. So what would you say are the barriers to the further development of solar panels, solar technology on board yachts especially? It's a question for all of you, including Nicolas, if you're still with us.
Yeah. So,
yes, I'm still here.
Yeah. Okay. So I would say we're always like trying to watch the next trends, and I think we could have like the next step with we're pretty much at the end of single junction cells. So it doesn't get much better than single crystalline silicon in terms of cells, and we're pretty much at the limit. So you can actually make incremental steps, but what you're looking at now is like you need to overcome what's known as the Shockley-Kaiser limit for a single junction cells, which is our 33%. And maybe we're close to probably like for single cells, maybe we're in the 26, 27%, like not on the module level where it's lower, maybe around 23. But we should be looking at triple junction cells. You're not really, so that's 3 different materials, and this could be, we're currently watching mostly perovskites. They're not really good in terms of like 2 perovskite layers plus the silicon layer, because they promise to have more or less double the efficiency. So then you have double the output, and that makes a much more interesting proposition. So that could be coming in the next 5 to 10 years. So that's what we see. In terms of battery technology, I think there's not like the leap that you could do. I mean, the physics is not really there for the leap, but it's incremental improvements, and there might be some discovery that could lead to a leap, like maybe lithium metal kind of batteries, but these also, they should be more prone to fires, so that's why maybe not as interesting.
Thank you. Someone else? Any of you? Julien, you were nodding, so I guess you have something to say.
Well, I agree with what's been said. I've been waiting for perovskite to hit the market for a while, and I remember the first edition of this conference 3 or 4 years ago. There were some presentations about perovskite being ready to be rolled out, etc. It's not yet the case, but it would be fantastic because in fact you could basically apply those films on top of the existing solar panels without reducing much of the output, so pretty much like doubling it. I see Lucas smiling there, so it would be interesting to hear his point of view. And battery, I think the leap could come from solid state, but yeah, we're still years away from that. Yeah.
Okay. Any other comment, Nicolas? Do you want to add something?
I just want. Yeah, the way we went, we tried to optimize the place where we can put the solar cells. And actually, that was our idea, to be able to put it on the mast, on curved surfaces, to optimize. So we are working right now on some different place. Of course, the cells itself, we are not building like all of us. So we are waiting for the technology, the same for the battery. So of course, we are following all of that, and we are making some tests. But I think the idea that we had today is to maximize the surfaces that is available on the boat to get the most solar energy as possible.
Okay, thank you. Any questions from the audience? Yes, if you can get a microphone.
Just a question about the power. Often it's quoted as the peak power, but that's normally at a standard test criteria, which is around 1,000 watts of solar radiation per meter squared at 25 degrees centigrade. In reality, it's often a lot less than that. And of course, it's impacted not only by diurnal variations, but also seasonal variations. So, for example, in Monaco, if you look at the daily power generation, it's about 25% it's 25% or less than the power radiation produced in the summertime. So there's a significant difference in terms of seasonal and diurnal variation in terms of the energy produced using solar panels. So when you're stating these, the amount of power that's used, perhaps there should be a gauge based on your location, the daily amount of power that could be produced, rather than the peak power in ideal conditions.
Yes. Can I? Yeah. I don't know if you hear me.
I'm not sure I got the question, but Nicolas, yeah.
Yeah, I understood the question. I think that, yeah, the question is more how. I mean, it's very difficult, like it was said, to exactly predict the kilowatt production. So we are talking in peak, but the peak is the optimal one, which of course will never be reached on all of the solar cells on the boat, or it will be reached for a very small time, but most probably will never be reached. After, it's very complicated to get, you know, if the boat is in Monaco, if the boat is in the Caribbean. So what we are saying the customer is that this is of course the peak, and that we have to take off a certain percentage for the real production of power. Like you've seen on our boat, we've put some solar cells on the hull. We get pretty good result with that. First on the early hours in the morning, but as well thanks to the reflection of the sun in the sea. So we got practically the same efficiency as on the flat surfaces. But obviously, yeah, there is no calculation today. There can be some cloud, there can be some rain. So yeah, that's why we have battery, and that's why all of us has a range extender, maybe, yeah, for at least the bigger boat, because there is no there is an intermittence into this production, like in the land, that we would say with windmill or with solar on land. Yeah.
Okay, thank you. Yes.
Well, I would like to add to that, and I understand the concern, and I think it has been actually a problem for the adoption of solar in the yachting world, because most of the boats that have been fitted out with solar have been sailboats, and panels have been fitted on top. But most of these panels, you have the cells actually in a string, and once you have one cell actually shaded, that cell will drop to zero, and essentially you cannot pass any current through there. So the considerations that you have, I agree with them. It's like the temperatures effect and maybe shading from clouds and so forth. There are many effects, but usually we're talking about maybe 25%. What I'm really concerned about is bad installation of solar panels, especially on sailboats, because you have the entire rig up there. So once you only have essentially a shadow on part of the panel, you're not dropping by 25%, but you're dropping by 95%. And this really upsets the owners. And this has actually upset the owners in the past, because they bought, let's say, like a 10 kilowatt peak array, and they're getting 200 watts out. This is a problem. And this has been upsetting the owners before, and that's why I think like a lot of people, they have been down on solar in yachting. But this is really due to partial shading and bad integration. And there are ways around it. we're only starting now, and this is like thanks to the automotive industry, because they will have the same problem. Because once you have a solar electric cars, where there are like multiple propositions out there, once you park under, let's say, like a street light or like maybe a tree, if it's wired up incorrectly, you're down to 5% of the nominal output, which no owner would be happy about. So.
Great, thank you. Any further comment?
Anyway, we are used to do this kind of calculation also for the regular engine, and you can risk to lose 10–15% of the power if you are in the Mediterranean than in Dubai. And for our point of view, the answer is easy, because we consider the calculation of the power in the sea trial, because we need to respect a contract. Then there is a calculation area per area in according of the tabella that we can find for solar production.
Yeah, I think it's a really interesting question, and maybe it's something to think about in the industry, that on top of giving a figure of peak power, which is practical, right? Because that's what's installed, end of the story. But we could also give an energy production daily. And this could be per latitude and per season, for instance. Also, it's important to know that some panels do not necessarily emphasize on their peak power, but rather to catch energy early in the morning and late in the evening. So these guys might have a lesser peak power, but overall a greater energy harvest, which actually is what is interesting. We don't care at midday to have a crazy peak, but have nothing in the early hours or late hours. We prefer to have a good and consistent energy harvest. So I think that's one thing. And then about the partial shading, yeah, that's really a critical issue indeed. What we've done on the Zen 50 is the entire boat, for safety reasons, is in low voltage, which allows us to not have many strings of panels, because we don't need high voltage to charge. It's 48-volt main bus, which means that actually one panel is already enough. So we can separate each panel individually with a separate MPPT and charger, and that's it. So they are completely wired independently, and that's a point that was made by Stephen, and which is super important indeed. That's a very important consideration in the electrical architecture of the boat, basically.
Okay, thank you. I suggest to deal with you is that everyone must be hungry. So what we're going to do is that we were supposed to come to finish this session with the electrolysis and hydrogen production. And so what we're going to do is we're going to skip that one to keep it for back to after lunch, so we can start with it, because it's anyway in the continuation of the proposition of the topics we deal with today. So we can, we can make a break in a few minutes. I've got something else to tell you before. And then we will restart with that session about electrolysis and hydrogen production on board. We can obviously all see that most of the solutions that we're discussing technically today have to do also with the combination of solutions. And this is something that will be highlighted with the shipyards as well this afternoon. Before we get to lunch, I would like to ask Derek Munro, who's the yacht manager of Black Pearl, who's a very well-known sailing mega yacht, to come to the stage and then to tell us a bit about that combined solution experience that was implemented on board Blackbird in a very short, what we call inspirational speech. And if you would like to give our gentlemen here a round of applause, and thank you very much for your contribution.
Thank you.
I leave the floor to you.
Excuse me. Good afternoon, everybody. I'm Derek Munro. I was the owner's representative for the build of Black Pearl, which we started 10 years ago with Ocean Co. Probably a year and a half after we started the build, we started to look into all the technology which has been spoken about this morning, and some of it which is going to be spoken about this afternoon. So from a personal point of view, it's great to have a wander around yesterday and see all the young teams out there progressing with the solar, we're progressing with technology and foiling and everything else that goes into a sailing boat and keeping our future sustainable and green as possible. And so going on to Black Pearl, today I was supposed to chat to you about inspiration and moving forward, but actually, as I just said, I think the inspiration is downstairs, and I think what Monaco Yacht Club are doing now with this whole program is in itself an inspiration. So I was told to chat about new build process. New build process starts with a client. We sit down with a client, we go through his statement of requirement, concepts, specifications, reviewing and selecting capable shipyards, and obviously for Black Pearl we chose OceanCo because of their flexibility. The tendering process we have with a shipyard, contractual negotiations, so a lawyer becomes very, very important in the new build process. Then we have the lovely construction phase, which is anything from 3 to 5 years, depending on the complexity of the build. Sea trials, acceptance and delivery. Owner's team, generally speaking, is made up something like this: the client, his legal team, his owner's representative. If it's a 40, 50 metre boat, that's probably what you will have. If you're going into something 80s, 90s, up to 140 metres, you need a much bigger team, and these are the kind of teams we're using on our 120, 130 metre projects. And this is obviously because there's a lot to keep on top of. The PA is probably the most important person in that scheme, simply because of all the meetings that take place every day, keeping track of communications, work lists, dreams and wishes of the client, and obviously the shipyard. So you sit down with a client, go through what is it you want? Sailing boat, motorboat, custom production. How far do you want to go? What sort of price range? What sort of toys do you want on board? Do you want all the nightclub, the spa, everything else that goes with it? Come into the concept. Go through the preliminary GA. Sit there. The client will draw up his design with his design team. You take that to the shipyard. Shipyard then change it all. They put it onto one of their hulls and you modify it, and then you go backwards and forwards. And in the end, you come up with the design that you see here, which was Black Pearl. Now, you'll notice on Black Pearl's top GA there, actually the satellite domes and everything were on the flybridge. When you see us at the end, it's very, very different. Prescriptive. This is really, generally speaking, in the specification, what the shipyard have as their standards. They obviously have standards for construction, standards for glass, standards for everything else. This is the prescriptive part of the specification. And we go into performance. This is exactly what the client wants. And obviously with Black Pearl, our client wanted to be as green and sustainable as possible. He wanted a sailing boat that would do as much as possible. And at this date, we've had 24.5 knots under sail. We predict that we'll get up to 28 knots, maybe 30. The hull's designed for 30, but in reality, we'll probably only do 28 knots. And then we have the proprietary requirements of a specification, and those are the bits that the client really, really wants and that he negotiates with the shipyard, i.e. for you guys, I want those particular solar cells, I want those hydrogen cells, I want that particular battery, I want this regeneration system. That's the proprietary part of the specification. And put the whole lot together, make everyone happy, sign it off as your build specification. New technology. So when we as an owner's team look at bringing anything onto a boat, whether it be a TV, a lighting system, an engine, whatever it is, hydrogen, storing the hydrogen, everything else, we look at all of these parts of the process to make sure that it fits on the boat, that it can be engineered by the shipyard and the subcontractors, how much power it needs to keep it going, the sustainability, the weight, the space required, all the way through to, what's it going to do to that room? Do we need extra AC? Do we need extra airflow? Do we need extra security systems? Do we need extra ventilation, exactly like the batteries on Black Pearl? We sat with Lloyd's. We did a 8-month hazard test to make sure that we could comply with all their requirements. Same sort of thing that Fedship and everyone else are doing with all their systems. And then we build the boat. And on a typical boat, 80 metres and above, there'll be 500 kilometres or more of cabling. So that's a lot of weight, a lot of heat, a lot of everything. In fact, one of the biggest things I would say for the future is that we should cut down on the cabling. If we could start running systems, Wi-Fi or radio or anything else, that would make a massive weight saving and save a lot of time and energy. When we were doing Black Pearl, we looked at 3 different types of cells for our solar. Silicone, gallium arsenide, and SIGs. The gallium arsenide was what we were going to put on the superstructure. We had 62 square meters of space for gallium arsenide. And the reason we wanted that was the output. The output of gallium arsenide at that time, we were told, was 40%. We believe now it's up to about 44. They say it's going to become more, but the solar specialists in the room will know better than I do. And then we looked at silicone for parts of the mast, but we ended up going towards SIGs because it was lighter, not necessarily because it had the best output, but at that time we were getting 17 to 19% from the SIGs. Very, very light, very, very flexible, and ideal for the sails. So we spent 12 months with Zentrum testing the SIGs technology on the sails, pounding them, rolling them, stretching them, how they would glue, how would they be bonded, how would they be protected. There's 2,800 square meters of sail on Black Pearl, and we figured that we'd get 50% of that for SIGs technology. So 1,400 square meters of solar cells. In the end, we didn't do that. We've wired the whole boat. Every yard and all parts of the mast are wired for solar. It was possibly the last conversation I had with a client was, when are we going to do the sails? He wanted to do the sails, and I, as the owner's rep and the supposed technical manager, said, no, we don't want to do that. So the reason we didn't want to do that was because of this, regeneration. Regeneration on Black Pearl is obviously back through the shaft. We start regenerating at 10, 11 knots. That's when we get about 80 kilowatts of power. At 16 knots, we're running the boat free. No generators on. All the power's going into running the boat. At 24 knots, we've had 478 kilowatts back into the vessel. This runs the ship, runs the house, charges the batteries. This is one of the reasons we believe strongly that we will do a zero fossil fuel Atlantic crossing. But because of this, and because when we're sailing our regeneration is so good, in my opinion, there was no need to put solar cells on the sails, because the sails are out when I'm regenerating. So what we wanted to do in the end, and we finally agreed it, was to actually put the cells on the fronts of all the yards and on the tops of the yards. And we would calculate with that area, we'd be getting about 110, 120 kilowatts of solar during the day. And obviously regeneration, the idea of that was when we were at anchor, sitting in the marina, we'd still be making power because we're not regenerating, we're not sailing, so we needed to make power. The other thing we looked at with the client was whether we would put some small wind generators, little wind turbines, somewhere that you could put on, put off, because they don't look that pretty. But when you're at anchor at night time, obviously there's no sun, you're not going anywhere, but usually there's a nice little breeze. And the technology now is such that the little wind generators actually give quite good returns, and probably enough to top the batteries up and run it while the crew are on board. So that was our next consideration, and it's still in the pipeline, and we're still looking at it. This is how the regeneration works on Black Pearl. Pretty simple. Change the pitch of the propeller, sail along, power comes in through the electric motor, back onto the bus. And it's not changing. Here we go. Hydrogen. We did look at hydrogen, and we looked at hydrogen around about 2013, 14. But at the time, there wasn't one place or one supplier who would help us make the hydrogen, store it, compress it, and store it. So we ended up getting our suppliers at the time. I had a supplier in Canada, one in Italy, and one in Germany who would have come together to package it up. And we were about to do it, but as I said, it was 2013, 14. And at that stage, obviously construction was well underway. And the shipyard turned around and said, yep, we're happy to do that, but you're going to lose a cabin for one of your guests. And the client weighed it up and decided, no, actually, guests is more important. We'll do that on the next boat, which is good because nowadays, as you can hear, hydrogen is much easier to make. There's more suppliers and hopefully in the future, more supply of hydrogen. Personal opinion, having listened to some of the conversation this morning, I think one of the big reasons we're not more into hydrogen is because we're not making enough green hydrogen. At the moment, hydrogen costs, and hydrogen is being made by fossil fuels. And the sooner we can make more green hydrogen, the more we'll get clients buying into it, because the whole reason they want to do it is because they want to be seen to be sustainable and green. On Black Pearl, we have 8 modes of propulsion. We actually have 9, but the 9th one is not really listed. 8 modes. Silent cruising mode. That's when we use the battery power only to run the boat. Take it off the dock, go out into the harbour, hoist your sails, go sailing, make more power. Silent mode is the big winner for any sailing boat moving into the future. Quiet cruising mode is exactly the same, except for the fact we're running the generators and not using the batteries. Economical cruising mode, this is where we switch the generators off, run the main engines. While we're propulsing, we're also putting power back into the bus to run the boat. Normal cruising mode, this makes us just like any other motorboat. We're running the diesel engines to push the boat forward. We have a boost mode, which is when we're running with diesel and we use the batteries to give the boat an extra 3 or 4 knots of speed. Obviously, when you're designing a boat, there are other things that help make it more economical and much better. Hull design. Hull design is massive, and you'll see the change in hull designs that have come into the industry in the last few years. Black Pearl has, when you look at it underwater, very clean, very similar to a J-class hull. The hull was by Dykstra, and there are no protrusions on the hull of Black Pearl at all. One of the reasons we think she's so fast. Obviously consider HVAC installation, how we control that, running the fresh air, running the AC, because that's a massive load on the boat. Waste heat recovery, Malcolm mentioned it earlier, when you're using your solar for our gallium arsenide on the sections where we had that planned out, we had them mounted sitting up, A, for cooling to get some airflow, but B, we had pipes running behind that to take some of the heat back into the system. Air purification obviously is a big thing. COVID. Thermal insulation, we doubled up on all the insulation on Black Pearl from previous Ocean Co boats. We double glazed. We did a lot of waste heat recovery off all the exhaust systems, and as I said, we looked at it for the solar cells. Technical water, we take the technical water from the AC systems, we use that to wash the boat down. There is enough water made that we can do a 6-ton wash down every couple of days. And then, as we're moving into the process of, as an owner's rep, selecting shipyards, obviously we're reviewing all the shipyards. We chose Ocean Co at the time because they were very, very flexible, and that obviously was a huge benefit for us because there was a delay with the project and we developed a lot of new systems with them, so we needed that time, and a lot of shipyards wouldn't have done that because of the slots. Obviously we go through a tender process with all our shipyards, put together a package that we like, see what that's going to cost us, do a variation, comments back, feedback, develop the specification from there, get a decent price. Typical shipyard setup, in my opinion. CEO, this is the team behind us, and the project team, project manager is the person that, as an owner, that's who I'm negotiating with and sitting across the table with, and he has all of his team underneath him to support him, and obviously their team, his team, and my team sit opposite each other at tables and have interesting discussions. Contractual, sea trials. Best part of any new build project, go on the sea trials, check it out, make sure that all the things you've dreamed of or the clients dreamt of for the last 6, 7 years are actually coming to fruition. Realize that actually some of the stuff is better than you thought it would be. Happy client, Shipyard's very happy as well. And off we go, acceptance and delivery. Nice, easy process, but this is sometimes where the real serious discussion comes in. What work we want to do for the next year, what is in the warranty, what's still outstanding, what's not, what's my cost, what's their cost, everything else. And then you end up with something like this. And the sea there is, she's only blowing 10 knots, boat's doing 7 to 8 knots. Sails incredibly well. As you can see, she heels over just like any little 60-footer, 70-footer. She's a proper sailboat and a pleasure to be on. And that's, oh, I did have some points from today's discussions, which I thought may be relevant. On, we were talking, this guys talking about earlier with the batteries and everything about how their safety and everything. On Black Pearl, every cell of our batteries is monitored for temperature. We have a 2-degree variation. Alarms go off. We can separate those out, take them out of the system. The system keeps running. And so it's all part of the Lloyds, and I'm sure it's the same with DNV and everyone else moving forward. So batteries are actually intrinsically a lot safer now than they would have been 10 years ago. At hydrogen, when we looked at it, we were only able to do 350 bar, but so it's great to see the 700 bar coming in. New technology, progress forward, lots of options for guys designing boats now that we didn't have then. Wind, I'm surprised that we don't have more people looking at little wind generators because they're a lot more aesthetically pleasing than they used to be. You can put them down, you can put them away. You could design them into the structure so that actually you don't see them at all. Autonomy, this was the fun one we had on Black Pearl. The client actually wanted the boat to be able to sail without a crew. So we looked seriously with our integrator of the sails and the technical system for the rotation motors about how we could control everything so that basically the crew could go to sleep, it would get to a waypoint, tack, jibe, whatever, without the crew. Not only that, he was a big believer in the fact that if a Mercedes can park by itself, why can't a yacht? So we also looked at systems of parking a yacht without any crew. As an ex-crew member, I thought that was a really bad idea. So we kept moving away from that. Black Pearl, with our energy management, we put in a very, very simple system. 3 buttons. 1 button is crew only. And when that happens, the guest area systems shut right down. Lighting can only come on 10%. AC will only be at a minimum. Humidity control is at its minimum. And then we had number 2, which was the client and his PA, or whoever he happened to be traveling with, so 2 guests essentially on board the boat. And then full guest control, which is button number 3. Very simple in the engine room. 1, 2, 3, who's on board, all done. And that's one of the reasons, as I said earlier, that with the regeneration is how we, Ocean Co. and the team believe this will be a zero fossil fuel Atlantic crossing. Personally, I'm involved in 2 projects, both one a motorboat, which will be zero fossil fuel. I have a very interesting client who wants to push the boundaries, just like Mr. Berlikov did. And I think what we're going to find in the next 5 to 8 years in the industry, lots of really positive change. Where we're at now, we'll take a massive leap. So it's all very, very good, along with what's happening here at Monaco. I think as an industry, we should be very proud of where we're going. So thank you very much.
Thank you. Thank you, Derek. If you've got any questions for Derek, I think you can ask him while you're having lunch. We need to be back here by 1:45 and try and catch up with the missed time. So enjoy your break, enjoy your lunch, and see you here 1:45 latest. Thank you. I'm going to try to speak loud. If anyone who's near the door can help bring the people back inside, we would like to get started. In fact, we'll start at 2 o'clock sharp. So you've got 3 minutes to come back in. Please make your way back in. Could you please all make your way back in? You can take your dessert with you. Please, can you make your way back in and take your desserts with you? We have to conclude by 4:15. So if you don't want me to cut you short, please make your way back in. Take your dessert plate with you. Okay, so I think they got the message, more or less. Try to shout not too loud. In order to try and speed things up, I'm going to already ask Alessandro Balzi from the Baglietto shipyard, energy department manager, if he's here and not still outside. Don't know. Alessandro, not here. Okay. Thomas Lamberti, the CEO of H2 Boat, to come on stage as well. Yep, if you can please take a seat. Then we'll have Christine Frank from Aquan, who's the CEO of Aquan Yachts, and Luc Boursery, who's a systems engineer on board Energy Observer. Thank you. Sorry, we're still going to have people coming in, but I suggest we still get started. Otherwise, we could wait almost the whole afternoon. Please, everyone, can you make your way back in? We're about to start. Thank you. Okay, so this was meant to be the last session of this morning. And since we're talking about being energy autonomous, we talked about solar, we talked about wind a bit as well, and we're getting back to the hydrogen topic, but also combination of solutions. And we'll have basically an explanation from an actual experience of what's been done on board Energy Observer when it comes to electrolysis and production of hydrogen on board and storage as well.
And we'll be looking also at the developments from various shipyards. I don't know if Mr. Balzi will be joining us to explain the approach and how to go about it with all the constraints, difficulties, challenges, but also solutions that are being brought forward by various shipyards to try and be as energy autonomous as possible. If we could start, I suggest we start then with Boursery, systems engineer, because he's got a huge experience in that question of producing energy, producing hydrogen and storing it on board. Your mic is on?
Yeah,
Okay,
I think so.
good.
Thank you.
Floor is yours.
Yeah, so I'm a system engineer on board this vessel, Energy Observer, that is sailing around the world with most of the technologies we talked about from this morning. So solar panels, the ocean wings from VPLP. So we do electrolysis, we store it, and after we use it thanks to a fuel cell. And so the boat is sailing now from 2017 around the world, and we go to test these technologies and to meet people around the world to talk about it and talk what's being done for the transition. So this boat. On this boat, we have 202 square meters of solar panels, mostly provided by Solbian, that was here this morning. So for a total power peak of 33 kilowatt peak. So how it works, we will basically produce some electricity from it, store in our batteries, and where our batteries are full in the middle of the day, with this excess of energy, we will make some hydrogen through our electrolyzer and store it in our 8 tanks up to 350 bars. So we have on one side our lithium-ion batteries for 100 kilowatt hour. This is what we call the short-term storage. We will basically have a day or a day and a half with this. And we have the hydrogen storage for a total energy storage of 2 megawatt hour. And by using it, 1 megawatt hour will become electricity and 1 megawatt hour will become heat. So basically, in terms of electricity, we have 1 to 10 between lithium-ion batteries and hydrogen for approximately the same weight. So this is when we can understand that hydrogen can be useful. And so basically, usually I'm on the boat, producing this hydrogen, using it, so I will try to share my experience about it.
Shall I ask you the question first? How difficult is it, or how simple is it to produce hydrogen on board and store it? Because this is what everyone wants to know.
Yeah, just a simple button for me. Now, sometimes we have some small issues because we still are prototypes, but basically we have energy management systems and a lot of safety, and so everyone could do this step of pushing the button to say, let's store the hydrogen, or even put a parameter to say when the batteries reach a certain level, begin to do electrolysis. So it's not hard to make or to use hydrogen since you have a good energy management system and the good protection that makes that you feel comfortable with this, because even if there is an issue, it will stop just at the right time.
Does it take much space on board, and how complex is the integration? I mean, that's been quite of the key words today so far, integration.
Yeah, integration. So I was not there at this point, but what they've done is they typically took commercial electrolyzer that they adapt a bit to fit the shape of the boat. What you can see on the picture behind me, it's the electrolyzer. It's approximately 2 cubic meter, but we have to take into account the compressors also for the storage, of course. That will take an additional 1.5 cubic meter approximately. And yeah, in terms of the integration, what they've done, as we have production and usage of hydrogen, they mutualized some parts of the system for it.
Okay, thank you. I'm sure there will be plenty of questions. Shall we then move on to Christine, who's going to tell us more about the Aquan boat, which is a combination of all solutions.
No, but so we are working on this Aquan 1, which is a green hydrogen propulsed catamaran since 2018. When we started, hydrogen was seen as something very dangerous, but that has changed completely. Now it's very cool. We started with the product briefing in asking potential users how they would use the boat, what trips. And that was key for laying out or for put the right dimensions of the energy system. And we are similar as you with energy production. So we have a solar roof. And that for short term generates electricity going into the battery. Long-term storage is if we have a surplus of energy, then there's an electrolyzer who generates hydrogen out of seawater and sunlight with electricity that is stored into tanks. Yeah, that's a long-term storage. We can store. Why did we go for hydrogen? We can store much more energy on board. We have 4,000 kilowatt hours in the tanks because we want to provide independence. The key challenges on the way were not technical, I must say. We were confronted that 2 potential suppliers were acquired by large groups who decided that the maritime sector is not interested for them, but more like trains and vans. And yeah, that was difficult because then we had to look for others. Since the beginning, we are working with DNV, who clearly said what they want, meaning that everything we select is DNV certified. That limits choice quite a bit. But I think that will change in the future with more and more companies entering the market. They also are very helpful in the safety regulations of the boat. So the energy system is specified in 3 rooms. One is the room for the tanks and the compressor. Then we have a separate fuel cell room with electrolyzer, and then we have another room area where we have the batteries. Yeah.
So it does take much space into your yacht as well. We're talking about
actually, our IP is to have a very compact energy system because space and weight is very critical in the catamaran. It's actually very compact. Yeah.
So you don't have the issue of having to remove one of the guest cabins?
No.
No.
No, no. But we also were lucky when we started. We were able to onboard key research institutions that has spare capacity. Nowadays, you would not get that capacity anymore because of automotive and other industries.
Because we are of no interest to anybody in the industrial world.
We are just a very small company, but we were really lucky. At that point in time, they had the capacity. They're still helping us, but nowadays, no, we would not get them anymore.
Okay, quick question to well, to you especially, and then we'll speak about H2 boat. From a cost perspective, the fact that you're looking at producing your own energy on board, what, whether in terms of percentage or overall cost, it adds to the total building the yacht?
Yes, it adds. But as a business, we are free to determine the margin we want. And we decided those who own the company decided that we want to push the technology in the market and don't need to earn the normal margin on yachts. So at the moment, we are in the process with some people, some prospects, hot prospects, and that's the cost price.
Okay, and how much then of the energy provided on board, I mean, from what you said, is like almost all the energy on board is provided through the fuel cell? And the production of hydrogen?
Yes.
Okay. So
if,
do you
if,
like...
If you stick to a certain behavior, so if you only use the catamaran with 18 knots, then it's not possible. But it could go on forever for between 4 and 6 knots. But the use cases shows that you go, for example, from Monaco to Saint-Tropez, it was 60 knots, and then you are there for a day, and then you can come back without problems.
And how much hydrogen can you produce, like daily?
Excuse me?
How much hydrogen can you produce daily?
That depends on, you know, there was a very good question in the beginning about like the solar cells. I think we need to create a standard for comparing solutions. At the moment, you cannot do this. So I would need to say, okay, what conditions of sunlight, temperature, whatever it is, then I could get a proper answer.
Okay.
Yeah. But interesting is from talking to prospects, a huge barrier to entry is that there is no refueling infrastructure. Even if you say we are autonomous, they would love just as a backup in the Western Mediterranean a refueling infrastructure. That's why we start talking to marinas.
So that's one of the difficulties, because you cannot guarantee in a way that you're going to be fully autonomous.
Well, we can guarantee, but they don't know whether they don't want to go always in higher speed.
Okay, so you need to have the backup of being able to refuel.
For the mindset, yeah, to have
For the
peace of
mindset.
mind, yeah.
Okay, which at the moment you can't do.
Well, we
complicated.
know some projects in marinas going on, but this is the hen and egg phenomenon that the marinas say, okay, how many boats are coming? And then, yeah, so.
Okay, I have some further questions, and
Okay.
I'm sure they'll be from the audience. So now about H2 boats. Thomas, can you tell us more about your project?
The idea is the same idea that Energy Observer and Aquon had. I mean, we started working on hydrogen, and then in 2012. And we started working on the fuel cell, and then we understood that the problem is not only the fuel cell, you have to talk about the storage of hydrogen. Then you move to the storage of hydrogen, and then you find that the problem is where to refuel the hydrogen. And then you start discussing how to integrate these things, and you know that there are some rules, requirements that are not still there. And there is no possibility to refuel in ports because there are no rules in ports, and so forth. So the point is, we are working on hydrogen. We believe that hydrogen can really be used from the technical point of view, is a solution in order to extend the range autonomy of battery, not to replace diesel engine, but to extend the electric autonomy of batteries. So the only way to install and use hydrogen technology today is to have on board your own capability to produce your own hydrogen. And this is the reason why we are bringing on board the electrolyzer. Then the differences in between our project ideas and the one that has been explained is that we are using a different storage solution, that is metal hydrates. This storage solution is a solid hydrogen storage solution that works at low pressure and ambient temperature. It means that we can refuel the metal hydrates directly from the metal hydrates directly from the electrolyzer without any hydrogen compressor in between. So we are more efficient in these terms. And since this storage system is heavy because it's made of metal, we patent different solutions in order to integrate this storage in the keel of sailboats, mainly, where the weight is already used in order to balance the boat. So finally, the weight and the volume of the hydrogen storage system is for free. At that point, you'd only have to install on board the fuel cell and the electrolyzer. And we know that the fuel cell and the electrolyzer are quite compact systems. And this perspective can open new scenario on how to use hydrogen to extend the availability of electricity on board. But I'm quite sorry to say that we cannot replace the diesel engine with hydrogen technology today.
You mentioned sailboats. I mean, like storing it into sailboats. Why not motor yachts then?
because we also do work with motor yachts. The point is, in our vision, we want to use green hydrogen and produce our own hydrogen using renewables that is coming from the sun, from water and whatever, on board directly. And you can, we made some studies and we proved with a small boat, sailing boat, a proof of concept, 7-meter long boat, that it is possible to produce your own hydrogen and energy on board. Why on board a sailboat? Because the sailboat's consumption are fewer, and still you have the sail as a main propulsion system. When you move on board a motor yacht, okay, the power required from propulsion is 100 times more the power that you can really catch from the renewables. Okay, it's a question of a point of energy density, power density, sorry. But still, hydrogen can work, in this case, for motor yacht, as an energy extender. So you use your own electrolyzer in order to bypass the problem of refueling, but you use electricity coming from the port, so you are not really green hydrogen. Okay, it depends on the energy that is coming from the port. You don't know, but this is just a way to refuel your system. Indeed, we are working with Baglietto. Baglietto is installing inside this prototype ship, because we are talking about a super yacht, 52 meters yacht is a ship, something like 2.2 megawatt of electricity in terms of hydrogen. It means double in terms of hydrogen. It means kilograms, tens of kilograms of hydrogen in the form of metal hydrates. And this is possible because the boat is quite big. Okay, so it is possible also with motor yachts. And there is another project with a 13 meters boat, a regional project in Italy. We are working on this also with Vulcan, for example. There is somebody from Vulcan in here. And we are using the same concept, metal hydrates to store hydrogen on board.
Okay, thank you. Could it work with the liquid solution that we talked about this morning or not? It has to be the metal hydrate option for storage.
Metal hydrates, compressed hydrogen, and liquid hydrogen are the means to store directly hydrogen. Whenever you move from hydrogen and you use a different alternative combustion fuel, okay, a different energy vectors, you are using a completely different system. So the system that we saw this morning, if it is liquid hydrogen, is one of these, okay? And we are talking about the similar performances in between them. Just to give you a raw number, okay? 350 bars means 20 kilograms of hydrogen per cubic meter. 700 is the double, okay? And liquid hydrogen is similar to 700, so a little bit more than 700. Metal hydrates are in between 350 and 700 bars in terms of energy density, okay, capacity.
Okay, thank you. So it means that you've sorted the compressor issue. And that was one question I had for Christine and Luc, is how do you handle the complexity and the energy it costs to compress your hydrogen once it is produced? I mean, how much efficiency do you lose by doing that process, and how complex is it? Is it like, you know, Luc, you said you push a button and then you run the electrolyzer, you produce your hydrogen and you store it, and, you know, easy. The compression stage or the complexity of that, I mean, if tomorrow I'm a yacht owner and I want to install my electrolyzer on board, and is it simple to do as a process and to use it?
Actually, on Energy Observer, we communicated about it. We had some issues at the beginning of the project with these compressors, the membrane that we had, because we have actually two compressors, two-stage compressors, one that goes to 150 bars, and the second one from 150 bars to 350 bars. But this is, in my point of view, an issue with the readiness of the technology, maybe, and also we try not to use it. We don't electrolyze when we are at sea, because this is one of the parts that is in movement in the system, while in the electrolyzer we have almost no part in movement, and fuel cell for the exception of the pump. For the auxiliaries, there is no movement. So this is one of the issues. These compressors with this pieces in movement, it can be sometimes fragile. But yeah, in my point of view, it's also that the readiness of the technology, and we are a prototype.
Christine?
So the owner or the person who uses the yacht would not, the goal was that the person should not see any difference in handling the yacht just because it's hydrogen. I mean, you get a briefing, but we have an energy management system developed that is key for the integration of all parts and communicates like if we have an energy then surplus, then automatically we produce hydrogen. If not, it goes, you know, in the battery. So he or she would not have to do anything special because this is bad for the acceptance of the technology. Yeah.
Okay, so for the three of you, whether it's the metal hydride solution, which means no compression, sorry, or the readiness of the whole technology of electrolyzing, compressing, storing, and using, you're happy with what you've got, and that we can confidently say to the yachting world, well, you can actually have an electrolyzer produce, store your hydrogen on board. We were talking about Black Pearl earlier and the new projects that they may have, so that they can confidently go for it.
I think our technology, as we laid out, our energy system is only valid for a certain size of a yacht because we have hydrogen in the form of gas. So this can only handle a certain capacity of energy and energy then consumption, but up to, I would say, 80 feet, that's okay. There's a lot of information on 700 bar tanks. When I checked earlier this year, there's no 700 bar tank that is DNV certified for the maritime sector. And that is quite costly because when we have certain tanks that we needed the certification to be done to get them certified for the maritime sector. To do this again, this is quite expensive than for the 700 bars. So there would be, I think, the whole process would be facilitated with more cooperation within the industry to push forward the industry. Otherwise, some companies would not offer anything for the maritime sector, possibly.
Yeah, and in my point of view, so I said it's easy to use, but it doesn't mean that it's easy to be autonomous. Thanks to it, depends on the application actually. And for me, there is 2 points. It's to be flexible. We talked about it this morning. Other people will be able to make compromise on the speed, on the load on board, and also the storage to keep space for the storage. Because yachts are not used most of the time, so you could do your electrolysis during most of the year. If you are able to store it, and you're okay to store it, you could have an autonomy, longer autonomy when you go at sea, actually. But it's a matter of compromise again. So,
well, from my point of view, yes, the solution to have an electrolyzer on board is the only solution to start having a product working from tomorrow, not from 3 years up to now, okay? And we are working in order to launch a product next year. And we are already working with some shipyards in order to integrate this solution. Thanks to the metal hydrides and working at low pressure, we are able to certify, and we are certifying our storage solution whenever the size of it with RINA, for example, the Italian Classification Society. Thanks to the electrolyzer, we don't care about the refueling because we are able to refuel, as you do as well. So, yes, this is a solution that enables the introduction of hydrogen in the marine sector now. Okay, so I think this is quite important. And we hope to introduce this system more and more, starting from the pleasure vessel. And a very important point is the integration. So each boat is different, and a point is to put a fuel cell and an electrolyzer and the technology on board like this. A different point is to integrate everything, to keep advantage of the weights, to keep advantage of the integration of everything, to have a good management of the energy on board. This is completely different, and this is where we want to work, and I think also they are doing so.
Well, we'll hear the shipyards tell us how they do it later in the afternoon. Thank you very much. Do you have a couple of questions from the audience? Or everything is clear? Yes, I don't have a mic with me. Well, I'll give you mine. Make the explanation short before the question.
Yes, short explanation. Well, thank you for the presentation, very interesting. I was wondering, what's the round-trip efficiency of your system? So electricity in, electrolyzing, storage, compressing, whatever, and electricity out. What's the round-trip efficiency?
I can say, for Energy Observer, we mainly consider that it's 25 to 30%, 50% loss at production and 50% loss at the usage. But actually, at the usage, it depends on where we are in the world, because when we went to the Spitsbergen, when we will go to South Africa, we will be able to keep the heat, the air and the water, while now we are near the equator in Vietnam, Singapore, and we need AC and not heat. So at this point, this byproduct is just losses, we'll say. So yeah, 25 to 30%, and can be more if we keep the heat.
Just to give you a few figures, okay? If you start from electricity, the efficiency of, and this is the technology performance, okay, of the electrolyzer is maximum 70%. Today we are working at about 63, 65%. Then you have the storage, and the efficiency of the storage is almost 100, okay? You don't have losses, you don't have the problem with batteries, okay? It's just a gas. And then you have the fuel cell, and we heard today that the efficiency of the fuel cell is about 50%. So without the compressor, we are able to reach something like 35 efficiency round trip. And in the future, we will be able to increase this up to 40, but this is it. This is the technology that we are using. But today I heard also saying, and I want to highlight this, that this way to use the energy starts from green energy. Okay, we are already paying the costs of being green. If you use diesel, if you use any other source of energy, you are not paying these costs. So we have to keep in mind when we compare the technology, hydrogen batteries with traditional diesel technology.
Thank you. No more questions? Okay, great. Thank you. Thank you very much. It's been very enlightening. And please give them a round of applause so that we can welcome our next panel. We're completely changing gear in a way. So from the R&D side, we're now getting back towards the super yachting area specifically, and we'll be addressing what we call the practicalities with the classification societies. So our first panel about classification societies, welcome Engel de Boer, Yacht Segment Manager from Lloyd's, who should be here. Yes, please come on stage. And then we have Giuseppe Zaccaria, who's a Technical Director at RENA. And I'm sure that you'll be under a lot of pressure. I don't know if Jan Olaf can join on behalf of DNV, because he's got obviously a lot of experience working with DNV. DNV was meant to be here but couldn't make it. There's been some complexities having to do with airports nowadays as well, and cancelled flights. So you heard a lot of things about all the R&D side and the technology maturity. Now a lot of concerns seemingly is, and we've touched upon this, has to do with the refueling when it comes to hydrogen especially, and about regulations when it comes to new technologies. And I'm sure that as classification societies assessing risks, you have lots of things to share with us about the current situation, but also about what we can anticipate for the near future. So up to you to get started, how you want to go about it. Pretty open.
Okay, well, thank you very much, and thank you for giving us the opportunity to speak to you. I tend to stand up in this case. I hate sitting down, and I did this last time as well. I was here a couple of months ago, did exactly the same, so if you don't mind, I'll stand up. I can see you better, and you can probably see me a little bit better. I just want to quickly go back to the essentials as to why we are here today and why we are talking about sort of the energy transition. It will come as no surprise to all of you that, of course, globally we're in a situation whereby we're facing some climate challenges. None of you, or I would say all of you, will have seen the changes in the climate, the changes in the weather, resulting in extreme weather conditions, regardless of whether it's winter, summer, spring, you name it. Even recently, in Italy, for example, the disaster on the Marmolada is related, according to the news items, to climate change. What's happening currently in China and in Japan with the extreme weather conditions, again, is related to the weather change and to the climate change. So it comes as no surprise that there is a need for us as an industry to also address this very fundamental issue, which is why we're so grateful of the Yacht Club de Monaco and the Energy Challenge to speak to you and to move forward as an industry, which I believe is the most important thing. To put it in perspective, and I'm not too sure whether this was stated this morning, the shipping industry, generally speaking, produces about 2.9% of carbon footprint annually. So we are, for a small percentage, also guilty in the global warming effects happening worldwide. Part of that 2.9% is, of course, the yachting industry, but of course we need to take our responsibilities as well. Why do we need to take our responsibilities? Well, as has probably been stated earlier on, there are some ambitions, if not regulations, coming into force, which will ensure or which will demand the industry to reduce its carbon footprint by 50% by 2050. That is the ambition of the United Nations, of the IMO, International Maritime Organization, and they're now even considering extending that limit to 100% instead of 50%, which is going to be a impossible challenge, frankly speaking, because even if we want to achieve the 50% reduction by 2050, it actually means that by 2030, so that's in 8 years' time, 7.5 years' time, the carbon footprint of all ships, including yachts, will have to be reduced by 85%. So that is the challenge we are facing as an industry. Yes, I agree with what the previous speaker said when it comes to, are we going to get rid of diesel engines? Probably not for the time being, but we'll have to find a solution. But there are many solutions available nowadays, and they're being implemented. What we're doing about it, from a Lloyd's classification point of view, is that many years ago we've started the Lloyd's Registered Decarbonization Hub. We started that because we believe there is a need for leadership and there is a need for collaboration in order to find the appropriate solution which we can all implement. And the reason of us introducing the Decarbonization Hub is to accelerate decarbonization within the maritime industry in a technically feasible, safe and commercial viable manner on ships by 2030. So it is quite ambitious. And the Decarbonization Hub is a platform whereby we work with the industry, together with lots of familiar faces I've seen here today, but also with the major players in the general shipping industry. And it is within that sort of collaborative framework that we can only achieve what we have to set out to be. We can't be, like we are all doing here today, sitting and do not a lot. We have to move forward. And we've seen it today, and we can see it outside. The solutions are there. they're technically feasible. It is possible. Yes, it comes with some complexities, and there is a need here and there to change some of the regulations, particularly internationally. And one topic I did want to get onto later, perhaps when you have a different question, is one topic I haven't heard yet is nuclear fuel, but I'll talk about that later. Thank you.
Okay, thank you. Yeah, we'll have some questions for you. Mr. Zagaria, if you would like to tell us a bit more about your views on from Marina.
Thank you. Thank you. Well, I do believe as a classification society, we need to share with the shipyards, designers and ship owners what is happening at the regulators level. It's quite common to talk about sustainability. We do believe if you don't have a consistent set of regulation, there is also no sustainability. So sustainability passes also through the rules and regulation available that should not be let's say, confusing and should give a clear way because, you know, this is going to influence the investment for the stakeholders. As a class, we also do believe when you are a group, as Arena is, when you are working in different sectors, decarbonization is not just a shipping challenge, but it's a global challenge. So it is extremely important that you share what is happening in other sector. Technology could be industry, space and defense, it can be energy sector, that you bring back to the shipping in order to see how it may benefit, you know, for the yachting. Finally, I mean, I put on purpose in my slides, I put energy transition by yachting because it is with, I mean, a kind of pride that yachting is pushing the shipping into decarbonization. It's providing a sort of solution and lesson learned that the traditional shipping, it's actually not delivered. I mean, also because for normal shipping, the drivers are different, but also because the way the ships, normal ships are designed and built is quite different. So I'm seeing this one. I spent several years in Asia, and I do believe the support that what is happening in the yachting will benefit the total industry to achieve the decarbonization. Thank you.
Thank you. Jan, for a few words before we start with questions.
Yes, as I've been asked to jump in because DNV is stuck in the airport strike in Oslo. It's very good to see it from a user's point of view. We have so far certified or been responsible for the 50 vessels have been certified with our batteries. And my conclusion is that would never have happened without a very close and active activity of certification society, in our case DNV, but we also had 1 or 2 vessels with others. Because as you correctly said, it's not, Rina, it's not you who get the rules. You have to find rules which the government bodies think is right. They might not have the full competence. You have the competence to tell them that's a nice idea for reducing it, but maybe we find other ways. And I remember that you are often saying, let's find solutions which are feasible, which achieves it. A normal regulator might have great ideas and say it should be like that, and it's beautiful, wishful political thinking. But we need the partners who know the business, and that's why I think it's extremely important that there's a very close cooperation between the technology providers and the shipyards. You experienced that the first time when we launched the Vision of the Fjords, which was a fantastic vessel. It's aluminum, it's carbon fiber. It has 400 passengers, and the government said, that's much too dangerous to put batteries on. Imagine the carbon fiber might burn, and we heard about rumors about explosion and thermal runaway. It was very tough and a very close cooperation in that case with DNV to said, yes, but if you do it like that, it could work. And if you do it like that, it might work, but we need another kind of cooling. This total understanding is extremely important.
important for you to build up and to convince the government that it works. And in our case, it works over time. We really had built already most of the vessel until the government decided, okay, those are the rules, and let the DNV certify that our rules are here. So you have a very important role.
Thank you. Brings two questions to my mind when I hear you say that. The first one is if I consider, let's say, any new technology. Okay, we've been talking a lot about hydrogen and the implementation of hydrogen on board, but there may be other solutions. As a regulatory body, how much time does it take between the maturity of a solution, where it's no longer R&D, but it's actually properly mature, known to be mature, and the implementation or the possibility for a shipyard to say, okay, fine, you know, the rules are there, easy, we know what to do, we know what to follow, we'll do it, we'll implement, blah, blah, blah. And everyone will be happy. How long does it take?
Yeah, I take this, well, we don't have a crystal ball, of course, for these answers, but we are talking about years. Anyway, it is extremely important to have in the yachting industry such, top-notch excellence startup company like H2 Boat of Mr. Thomas Lamberti. There are so many other of these realities, okay, that help so much to marinize the technology. Because when you have a technology, a solution that works on the land, nobody can be sure how it's going to work on board. You need systems that are more compact, they are more efficient, they work under rolling and pitching. Engine room is not such a large spaces. And on the other side, you may not have so many crew on board. So it may not be all the time under watch. So you have to balance a lot of different requirements in a limited space. So indeed, we are talking about, we are on the scales of years. Of course, we may have a short-term, medium-term, and long-term measure. This is how European Union and IMO is working on it. So in my opinion, if I would put on a diagram, I would say we are quite ready for methanol, but to have something, the scale up of something working on green hydrogen, we still need years, actually.
Can I just add to that? So, and I absolutely agree with you. Generally speaking, and it really depends on how you pose the question. If you look from the design concept phase all the way straight through to delivery, you're probably talking 5, 6, 7 years. That's how long it might take. If we're talking about novel fuel, something completely new which nobody has thought of before. However, nowadays, when we talk about methanol, when we talk about hydrogen, when we talk about battery power, when we talk about other alternative forms of fuel, the technology is already there. We are already implementing them. We're currently dealing with some 20 to 25 projects, yacht projects, globally, dealing with either methanol, hydrogen, or other alternative fuels. The technology is there. That's not the barrier. So if it does take effort, because they're all based on risk-based design, which means you have to do a proper risk evaluation, and it does take time and effort, because no single ship, no single solution is the same for every ship. But if you use one of these known technologies, whether it's methanol, hydrogen, batteries, there shouldn't be a big difference to building it in accordance to the same schedule as a big motor yacht nowadays, 36 months. Because the technology is there. And the pace at which it is developing, I'm pretty sure we will see more yachts entering the scene in the near future. What is disappointing is if I compare it to the general shipping industry, 61% of all new orders worldwide, and I'm talking about, not about yachts, I'm talking about tankers, bulk carriers, you name it, all sorts of ships, they are all ready or already implemented with alternative fuels. 61% of all new orders globally as of 2022. That's an increase of 33% compared to last year. I'm afraid, and I haven't seen the figures, but I don't think we've gone to that extent yet, good to see there are pioneers within the industry willing to take the leap of faith and move forward because they strongly believe in their products, like a lot of the presenters here today, but also some of the owners who are willing to invest large sums of money and then sharing the knowledge worldwide. Fantastic. And this is where I absolutely agree with you. This is where we should be, can be, and see it as an opportunity to be at the forefront. Don't see it as a threat. See it as an opportunity, please.
Thank you.
Just to add, the idea that you all share information and build common competence is extremely important. What we learned, we're just certifying now the next generation battery systems. And besides of having, as I said, making 3 thermal runaway tests separately, all that, the DNV, and I'm sure you ask, and we want to control how the manufacturing process is of those batteries. So it doesn't help to have a great system which works. They also control with the production of those batteries following very exact quality rules. And we cannot certify a battery unless we can show that this is a series production, which then DNV or others can check if they are produced in a systematic way. And that means the picture is much wider and the quality understanding much wider from those associations than we sometimes believe. In DNV, I know that's a foundation, so the money they make, and they're not cheap, they spend that on internal research. I guess you are the same. So it's not that you want to make a owner richer. It's that you want to improve the quality and understanding of your services more and more.
Thank you. Brings me a question on the R&D side, because that's part of today's topic, is where do classification societies see the limit or the barrier between what's the R&D and the prototype and the actual certification process of a serial production, in the sense that, I mean, we were talking with like Derek earlier about, you know, the whole process they went through with Black Pearl. But when you think for an owner to say, I'm going to implement that new solution into my yacht, well, I don't want to be deemed a prototype. I want to be, you know, certified, classed and everything without being deemed a prototype. I want to be able to have my passengers on board, blah, blah, blah. So when you talk about the components like the batteries or the fuel cells, where do you draw the limit basically between what's, okay, once you've got, I mean, to obtain type approval, obviously you need to start getting into like serial production, and that complexifies matters. So for a yacht owner, it's pretty difficult to determine what technology they'll be able to use based on something that could be approval or certification to come, but that is not there yet. How do you answer that?
Well, I think what I don't like in your question is the word limits. Because why should we set ourselves limits? I don't, you know, I think we should look beyond the boundaries, beyond what the rules and regulations say, beyond what is actually possible, because that's where we're going to find the solutions for the future. And we should be open-minded enough as classification societies, as regulators, to deal with it. Yes, of course, we need to stick our finger in it at times and say, well, hang on a minute, that's not right. That's unsafe. And we will stand up and make sure that that is either rectified or that particular technology is not even possible to move forward. What we have introduced within LR is something called the Safety Accelerator. It's again a cooperation, the possibility for young startups to come and join us, and we'll get them connected with all sorts of larger companies within the marine industry to see whether their ideas, concepts are actually feasible. And we'll do that in a very short period, in a period of 3 to 4 months, to do that evaluation, just to see whether it is possible and to then encourage further financing of this startup through the connections we have in the industry to make it move forward. So at times you need to switch quite quickly, because if not, you'll be spending 5, 6 years investing your time and money into something which is then not feasible anymore. So you need to be quite dynamic.
Okay, thank you very much. There's time for one question to this panel. No questions? Perfect, you're great. Sorry, there's one, okay.
I'm sorry. One quick question. We haven't talked about the cost of I just arrived, I haven't been here this morning or anything, so I'm sorry I'm a bit late. Perhaps you have talked about it this morning in other forums, but the cost of the alternative fuels, the cost of the various technologies is important for yacht owners, but I guess even more so perhaps for commercial operators of ships. I was just last week on a ship that is a diesel electric dual fuel, so diesel and LNG. It's hybrid, it's got batteries, and it's a relatively recent ship. She was delivered last summer, and we were up in the Arctic. And I said, what are you running on now? So I was visiting the engine room, everything was completely silent. They were running on the batteries, it's fine. But everything was set up for running on LNG. When the ship was planned 5 years ago, 4 years ago, the cost of LNG was half of diesel. Today, I didn't check this myself, but I think they said the double of diesel. So there's an unknown there, which can they throw the spanner in the wheels. Any thoughts about this? How this could evolve? How this could affect, particularly in today's situation with the war in Ukraine and energy prices are rising?
Absolutely. It's a continuous battle of changes and challenges we have in that respect. That's not just valid for us as an industry. That's just valid for all of us. And generically speaking, look at the fuel prices going up for your cars or for the heating or air conditioning in your house. It's ridiculous the way it's going, and it definitely has an effect on the ability to move towards alternative fuels if they are a lot more expensive. On the other hand, because of the expenses, it seems to release quite a bit of funds to look into other alternative solutions, which is why earlier on I briefly mentioned the fact of nuclear fuels. And everybody might be thinking, hang on a minute, nuclear fuels, are you crazy? Well, if you nowadays look at the possibilities of nuclear fuels with molten salt reactors being capable of generating up to more than 50 megawatts of power, or hot rod reactors being capable of generating from up to between 1 and 15 megawatts of power, perfect for yachts. No serious environmental consequences, with a decay life less than 100 years, all low pressure, and when it fails, it becomes inert. The only reason we're not using it is regulations, unfortunately. So that was one of the points I did want to put forward. Look further ahead into the future and think about the possibilities. But yes, of course.
It could be a catalyst, become a catalyst, perhaps.
It could become a catalyst. But of course, fuel prices, steel prices, aluminium prices, et cetera, are all having an impact on R&D, amongst other things, yeah.
Sure. Thank you.
Yeah. I would like to add a few comments. We more see what is happening in the fuel cost and the projection that is not going to decrease. We hope that is, first of all, a push for the technology in order to improve. We do believe it's the starting, the foundation. It's always, the hydrodynamics part, the propulsion system, a proper, management of the design point of the vessel. If you remember what happened in 2013 and 14, how much the price of fuel was skyrocketed. That was a season where we saw, some flourishing of, some kind of solution for hull and the hydrodynamics and for power management. We do hope there is first that push. Then, we hope, of course, the fuel price is going to decrease. Thank you.
For reducing the energy requirements, sure, this is seems to be obvious, yeah. To work on all sides of it, reducing the energy requirements in terms of resistance, hotel loads and everything, yes, for sure. What was interesting with the ship I visited last week was the fact that what seemed to be a very attractive concept when they laid out the ship and did the initial design and started building it, today they're not really using LNG because it's really way too expensive.
Yeah, and the LNG.
And how quickly that happened.
LNG, you have to spend money to keep it low temperature.
That's right.
It doesn't come for free.
And how one attractive concept became kind of, overnight.
Espen, we'll talk about it in your panel afterwards.
Sorry.
Because otherwise we can already start that panel. So
yeah, stop. Thanks. Sorry.
No worries. Gentlemen, thank you very much. Thanks for your contribution. If you'd like to give them a round of applause. Before we get back to the shipyard side for the last panel of the day, and I'm sorry you probably won't have time for a coffee break, we're going to do a quick logistics overview to talk about what's happening in the ports and marinas. It's been understood, I think, throughout the presentations today, the discussions, that there's an infrastructure question when it comes to the implementation of especially alternative fuels, new solutions, which have to do also with the electrification of the ports and marinas. So unfortunately, Mr. Lavagna from the Port Hercule and the SCPM could not be with us today because of, call it COVID. It's still around. So I would like to have Alex Bamberg, CEO of Aqua, to join us on stage. And then Thomas Lamberty to come back, if he's around. And last but not least, Mr. Philippe Bernard, the Director of Procurement from MB92. So welcome back and welcome. So the idea here is to basically, I don't know how much of the previous discussions you've managed to follow, but we know that, and you can see it in Monaco as well, the question has to do with also the infrastructure and the implementation of solutions, whether we talk about high-speed EV charge, I mean, not EV, but electric boat charging. We talk about infrastructure for hydrogen refueling, and or the supply of alternative fuels into the ports. I mean, this has to do with regulations as well. It's not going to fall further down, so it's fine. So yes, we'd like to understand what's the situation, how things are moving forward, what are the issues as well you may face when you want to offer your customers new solutions. Basically, have your view on what's the situation today and how you foresee the very near future. Whoever wants to start.
Testing 1, 2, 3. Okay. Hi, my name's Alex Bamberg. I'm CEO of Aqua Superpower, and we have been founded by Stuart Wilkinson with a mission to roll out high-powered charging for motor vessels or sailing vessels globally. And our model is, we have a funded model that we offer to marinas and ports or destinations, and we employ the grid connection, we upgrade the grid connection. We are building a software platform which will connect the smart chargers to all the end users who will be able to use this high-power charging network around the world.
Take the other one, maybe. My name is Philippe Bernard. So I'm representing MB92. So MB92, we are a refit shipyard for super yacht and mega yacht, the kind of vessel you can see on the side. We are based in Barcelona and La Ciotat, so not very far from here. Since 3 years, we are in the road of sustainability. So we definitely, in our strategy, go for becoming a sustainable and shipyard with a fuller decarbonization of our activities. Currently, so the first job was to adapt our infrastructure because, for example, in La Ciotat, we are in the old shipbuilding site, and the first step is to, when you do refit of yacht, to invest in the infrastructure to become more sustainable, means for electricity supply and all the investment you need to do. By the way, we will open a new platform, a 4,300-ton ship lift, where the sustainability has been thought from the beginning, from the concept of this new platform. And yeah, it will be much easier because everything has been thought to be able to supply the yachts and to also do the works on a sustainable way.
Okay, maybe you know me already, but the reason why I'm here is because I come from the University of Genoa, where I started working with hydrogen technology for marine sector, not specifically for boats. And probably the main reason why I've been called here is because of a paper that was called Smart Port, in which we tried to understand the possibility to use the renewables inside the ports that are produced by the boats, because we know boats have solar panels, solars and so on, to produce energy and give energy to the ports. Indeed, that was just an idea to exploit the renewables that are already installed on board. That finally, the cost effectiveness of this solution is not there. So it is not really a good idea, but you have to at least try to see this. And in order to respond to your question, yes, the problem is there, okay? So when you talk about the introduction of new technology in the ports, and you are talking about refueling of alternative fuels, hydrogen among them, or giving power to boats, okay? We produce a lot of studies, and it's a problem, okay? I give you an example of the port of Genoa. The port of Genoa, when you talk about ships, you have 4 to 6 passenger ships that are consuming megawatt power. So if you want to do recharge of batteries, fast recharge of batteries, or just you want to do cold ironing, so give power to these boats, these ships, you need megawatts. And so you see that we have a small power plant in order to power the boats. And probably the power plants pollutes more than the diesel generator that are already installed on board. So where is the utility to use this kind of system, okay? And so you started discussing about different alternative fuels, but then you enter inside the problems that we know, okay, about how to refuels, lack of rules, how to produce hydrogen. It must be green hydrogen, otherwise there is no point, and so forth. So in order to close the loop of sustainability, the refueling process and the ports is very fundamental.
I'd like to ask Alex, who's had experience obviously installing superchargers in a number of ports, building up the network. What's the situation today? I mean, what do you perceive in terms of electrification and the capacity for ports and marinas to adjust, to adapt on the charging side, but also to consider I mean, we're talking about production of hydrogen maybe on site. How do you see that evolution taking place or not taking place today? And what would be your suggestions to make things move forward?
We've done a lot of studies on this. We are focusing primarily in the first phase on a sort of sub-20 meter boat segment, which is very viable to use batteries in that alone without needing for regeneration of using another fuel, be it hydrogen or otherwise. And there's a significant number of boat manufacturers also believing in that as well. And we've been very successful in deploying chargers locally here and globally. In fact, we turned on our first chargers in the US last week and moving up to Sweden and other areas. So a very significant pull. On the larger vessels, or where you need a much longer range, yeah, there is, how do you provide that 2,000 or 3,000 mile potential range? And that is a debate, and that technology is out there. But as we spoke about earlier here on the panel, there is a lot to learn about, be it legislation, certification, and all these create a certain bottleneck for the technology to evolve. And the technology is there, but there's a price point and a legal possession. We feel the most efficient play at the moment is without doubt into batteries for that sub-20 meter market.
Thank you. Well, talking about regulations, you were mentioning about MB92 taking the sustainable approach and obviously converting or trying to do its best to a sustainable approach. So what are the initiatives that you're taking? And talking about regulations, how do you face, or what are the challenges you face when you talk to the authorities about what you want to do, and can you give us some examples?
Alors, concerning the regulation, so we are certified ISO 14001, and yeah, the regulations are not a barrier. We try to go above and to do more than what is today needed in the regulation. But the way I see our journey to sustainability, we have 3 steps. As we spoke, we supply the vessel with electricity or maybe something else after. But after, as a refit shipyard, we are performing jobs on the vessel from 1 week to 1 year. And our main objective is also to do these jobs on a sustainable way. So so to use more and more electricity. We buy electrical vehicles. When we can't, we want to use a non-fossil fuel. We are having a solar panel, like 800 square meter on a paint cabin, and we are developing also our solar panels. And yeah, so all this new way to find energy, but yeah, not only for the vessel supply, but also for the work we perform. And after, what I see as a 3rd step will be to support the transition of the vessel, but of the energy supply of the vessel. But I would say when the vessel will have hydrogen or more batteries or all this or more solar panel. So we need to be ready to do the refit linked to these jobs. But today on the big yachts, we don't see so many requests from our customers.
So you don't see many requests from the yachts, and then which means that you also don't have the opportunity to convince the authorities or the investment to be made into developing the solutions in the ports.
Yeah, changing the regulation will force actually this change to happen. Yeah.
Could I jump in? There's quite a good analogy with the e-mobility sector on the highway with motor vehicles. Many years ago, we pioneered some of the biggest networks in the UK, and when we started in 2010, nobody knew actually what a charger was. And we installed thousands of chargers in the UK over 3 or 4 or 5 years with many OEMs. And the upshot of that was that once you put the chargers in a visible, useful place, the vehicles came, and they came at an alarming rate. They were the biggest growth sector out there over the last several years. And the same is going to be true with the marine sector, where if we put the chargers in, we are thoroughly convinced that the boats will come. And that's the point we're trying to make. So how we break down and partnership up with premier sites to put chargers in, making it a viable transition away from carbon fuels. And it's about the convenience for commercial users, which is a key area, and also the leisure and sports side as well.
Thank you. So that's worked for the batteries and for charging. How do you see that happen with hydrogen being on everyone's lips, the possibility to implement hydrogen refueling stations in ports?
This is an issue. I mean, hydrogen is a very low density. So just to give you an example, the only ship that is using hydrogen is the submarine of the Italian and German Navy. Okay, to refuel this ship, you need at least 6 to 7 tier full of hydrogen at 200 bars. So it's a logistic problem to bring hydrogen, okay, just to refuel one ship. Of course, this is 1,500 kilograms of hydrogen, so usually the first application would not be so big, but in any case, the logistic is a problem. And if you start producing hydrogen in port, then you enter in the same problem that we have with recharge of battery. You need a lot of energy. Okay, much more than when you enter it with a battery, because the battery cycle is much better. So it's a problem. Okay, there is no unique solution. You have to try to work on this, and also the regulatory framework is different. It is quite important, because it is a different authority if you refuel any kind of fuels from land, or if you refuel from another boat. So where is easier? What is the best solution? And we are working on this. So many things to do still.
When you say it's different when you refuel from another boat and on land, meaning what? So like you bring a truck, it's easier than to have your station.
Not only technical, from the technical point of view, from the authority point of view. The authority that is involved when you refuel from a boat is different from when you refuel from the port, from the pier. So also the rules are different. And today we don't have rules, and the few rules that are guidelines that are there are not matching really, and they are different from ports to ports, from Italy to France to the north of Europe. And if you have to invest a lot of money to have a boat with hydrogen technology, and you want to refuel, you want to be sure that you are able to refuel in Italy as well as in Holland or in France. And still today we are not able to give this to our clients. And so this is a problem for also for the people, the clients that want to invest in order to have hydrogen on board, but still, without this reassurance, they cannot do that.
Thank you. I will bring it up tomorrow to the working group of the Hydrogen Roundtable with the Monaco authorities, certainly. Thank you. Any specific point you want to highlight about the path to sustainability in ports and marinas? Or a few questions, some questions in the audience?
A question about charging, or perhaps the shore power. Do you have any thoughts about having near-shore power, so something that you can moor to in the sea? Because we have more yachts, we have small towns here, little key length, and they may lay there for quite a long period of time. So any thoughts about that? Any initiatives that you know of?
There are one or two solutions out there from electrified buoys, and indeed if what we will do, if there's a commercial requirement for a vessel or several vessels, be it ferries or whatever, we would install those chargers and upgrade the grid around that duty cycle for those vessels. But clearly this is a growth segment in the first phase. We're trying to hit the biggest locations first, so we get as much awareness and education, and helps the transition away from the carbon fuels.
Thank you. Yes, there's a question at the back. Okay.
In terms of the hydrogen delivery, have you looked at alternative energy carriers so you can provide hydrogen on demand? So, for example, using methanol and a reformer in the port as the method of providing hydrogen to the vessels, then you wouldn't have the same issues with the infrastructure, the safety, etc.
Indeed, a different alternative fuels is one of the solutions, and from my personal point of view, is the solution for shipping. But at that point, you use directly these alternative fuels on board. So you refuel directly methanol or ammonia or whatever on board the boat. You don't use this to produce hydrogen and then refuel hydrogen on board. Okay, because of the volume you say, but in any case, what I see, at least, is the increasing interest in alternative fuels directly for ships. So I'm quite sure that in the future, more and more companies and industry will start using these alternative fuels for ships, and probably also for yachting, okay? Because when we talk about yachts, I mean, it's a ship. It's okay, and also from the ruling point of view. And so the intermediate part, to use alternative fuels to produce hydrogen in the port, can be a solution. We never investigated this, but definitely, yes.
Thank you. No more questions? Great. So instead of having a coffee break, because we have to conclude by 4:15 latest, I suggest we get straight onto the next panel, which is all about shipyard, naval architecture, engineering, where I'm sure there's lots that can be discussed, and with more room for questions as well. Gentlemen, many thanks. Thanks for your contribution. And so for the last panel, I'd like to call on stage, and I need to get 2 more chairs, actually. Yes, I need to get the 2 chairs on the stage. So we'll have Espen Oino, naval architect, Mr. Love, head of R&D at FedShip, Simon Bailey from Lateral Yachting as principal engineer, Dr. Bernard Urban, head of development and innovation at Lursen, Nicolas Grendel, design and proposal engineer at Damon Yachting, and David E. Bellini, electrical systems and electronics manager at Ferretti Group. I don't know if everyone is here, but if all of them are, we should have an interesting 1-hour session coming through. Thank you, gentlemen, and welcome. I must admit, this industry does need more women. We've got the 6 chairs? Great. So I leave it to you to introduce yourself very briefly, and then we'll start with some discussions about how to build sustainable yachts. Thank you. You probably don't have enough microphones, but you can pick whatever microphones, and yeah. Thank you.
Okay, shall we start? My name is Guido Loef, head of R&D of FedShip. Yeah, what does FedShip do? Building yachts, designing yachts, servicing yachts. So in my role as head of R&D, we work on various subjects, but sustainability is certainly one. We develop our own strategies, we set our targets, we look at our upstream process, our supply chain, our core process, our build process, so that's our own manufacturing process. But of course, also the use phase, so our downstream process, which is 94% of greenhouse gas emissions caused by FedShip. Our core process is only 2%, and upstream 4%. So yes, we need to be worried about the fuels of the future.
Thank you. Hello. My name is Nicolas Grendel. I work in the product development team at Damen Yachting. We are a Dutch master yacht builder located in Zeeland, which is a small speck of land, literally surrounded by lots and lots of sea in the south of the Netherlands. A bit like here, we have the beauty, but also are confronted with the issues of the sea very close to home. We're part of the Damen Shipyards Group, family-owned company in 3rd generation, with Rose Damen as the managing director of Damen Yachting. The group has over 10,000 employees and delivered more than 6,500 ships to date. And our CEO, Arnold Damen, formulated the goal of becoming the most sustainable shipbuilder in the world by 2050. So I'm very happy that we got together here today and can discuss how yachting can lead as an example for the maritime industry. Thank you.
Good afternoon. My name is Simon Brady from Lateral Naval Architecture and Engineering. So we're basically a naval architecture and engineering consultancy based out of Southampton in the UK. We work with shipyards, owners, in-service yachts for new builds, refits, consultancy, all sorts of tasks really. Principally, I guess I'm up on this stage also because we're the supplier of naval architecture services to OceanCo. So within this, within our work, we obviously get asked a lot of questions about sustainability, the future of yachting, and we see it as our mission really to kind of get that information out to prospective clients and to the industry as a whole, so that we can really have good frank debates and try and move the industry forward. So hope this panel helps that.
Thank you.
Okay, good afternoon. My name is Bernhard Urban. I'm head of innovation and development at Lürssen Shipyard in Bremen. I'm with Lürssen since 2005, and in that position we did a lot of different kinds of R&D projects, and more of those projects are dealing with improving sustainability of our yachting, of our yachts. And one of our main or biggest project right now is the Paxel project, where we develop a fuel cell which is driven by methanol, and our boss Peter Lürssen already announced about a year ago that we will deliver in the beginning of 2025 the first Lürssen yacht, which will be driven or will be powered by a methanol fuel cell. So I'm very happy to be here, and I'm looking forward to an interesting discussion, and it will be interesting who will be reaching or will be the most sustainable shipyard by 2050 maybe. I think everybody sitting here who is working at the shipyard has the same goal, to be very sustainable in the near future. Thank you.
Hello, ça marche. Good afternoon, my name is Espen Oino. I am a naval architect heading design office here in Monaco. We are, as naval architects and yacht designers, very much in the front line when meeting clients. So we have in many instances kind of an advisory role. What we have seen over the last few years, in particular the last 2 years, clients are taking a much more engaged approach when it comes to sustainability. Before then, it was mostly journalists who wanted to talk about it. As far as we're concerned, we are looking at, of course, trying to reducing the energy requirements through efficient hull forms. We have built a number of boats with very slender hull forms, lightweight, and in Australia, which you may know, the Silver series of yachts, 70 meters, 80 meters in aluminium, but which have a very low energy consumption when underway. We just sea trialed last week, 10 days ago actually, catamaran vessels in aluminium, 36 meters, that are even more slender hulls, so the energy requirement when underway is even lower. But there is more to the overall energy balance than just the resistance when moving forward. We know most yachts are actually spending most of the time when the clients are on board stationary. So we are at the moment looking at ways of capitalizing on different design geometries and to reduce the heat gain, in particular with regard to the air conditioning, looking at all systems on board to see how we can reduce the overall energy requirement when stationary. The picture you see here behind me is a model of vessels that my forefathers built for 4 generations. I thought it was appropriate to put it here because it's really, in many ways, when we're looking at reducing the energy requirements, it's going back to basics. And if you look at boating in its early days, there was no air conditioning. We didn't need electrical supply to charge our phones all the time and our iPads, and so on and so on. We didn't have screens going 24 hours a day. And I think part of the solution will be to go back to the basics and question the way we live, the way we enjoy yachting. Doesn't need to go as radical as this, but it is interesting. I just came back from traveling, and I was reading in the plane a little Norwegian yachting magazine. They were testing a wooden snecke, which is a traditional, like an Italian gozzo, which was 70 years old, and actually testing it against a brand new electric boat. Same dimensions, 25 feet, same power. And it was very interesting to see how in many ways nothing has changed between those two boats. The energy consumption was very similar, the experience was very similar. And I think we can learn a lot by looking at the past to project into the future. That's it. Yeah, we're about 30 people here in Monaco. Some of them here today, and some of them listening online. We have a number of different nationalities, and we work with most of the shipyards here. So yeah, and also with Lateral. So it's happy to be here. I think we all have the same goal. We all should work together and be more open about what we do as well, I think. And I think in reality, that's how it is. Voilà.
Thank you.
Thank you. My name is Michele Stroligo from Ferretti Group. I'm a naval architect, marine engineer. I had a previous experience in America's Cup with Oracle Team USA and the Luna Rossa Challenge. Right now, I'm the head of design I'll design manager for Ferretti Group, taking care about yachts from 6 to 42 meters. Our view about how to design and build sustainable yachts, of course, as we talked before, hull design is really important. CFD computation, since the concept of each new project is really important for trying to obtain the best results. We are talking always about compromises because, of course, the contents required by the clients are really important as well. One more cabin is important, sometimes even more important than the green request that we have as well. So using, of course, and investing a lot through CFD simulation in our design, we move also through materials. Lightness is really important, trying to keep down the pollution of our yachts. So we have different techniques that we use in our yachts, trying to reduce the weights, thinking, of course, about carbon technologies and some other technology that we are using to keep it low the weights. Of course, also as all our colleagues, we are thinking about propulsion systems and technologies. We need to focus not only on the drag and on the dynamic resistance, but also on the consumption that each of our project has as well for the hotel loads, for example. So it's really important that we try to cut each drop of diesel, trying to reduce the impact. No revolutions, but each step will bring forward to a greener yacht. We can see that from 2008, we launched already a hybrid yacht, the Moki 23 long range. And we can say that this year we will launch a full electric prototype. So we are investigating in all directions, trying to match a greener projects and greener solution for the yacht industry.
Thank you. Great. Great to have you all here. And I have a first question, I would say, to the shipyards, because a lot of what we talk about when it comes to what the students down here are doing has to do with R&D, and they do it in universities, they take part in the challenge, they bring innovation. So my first question to the shipyards is how much of R&D are you actually doing at the shipyard, and when and how? How much of it is by yourself, or is prompted by yacht owners who are willing to do stuff, or by as you said, as your boss is willing to do stuff. So what's the share of R&D? I mean, what's the importance of your own internal R&D? The naval architects are pretty happy with the fact that they're not in the limelight here.
Yes, well, head of R&D is very important. We spend a huge amount of time on it, and which is actually true. But I think Espen touched upon it. There is a substantial move that we see on the clientele side of it. So there are much more owners that are willing to invest, because at the end of the day, we are talking about substantial investments. So what we see is that owners start to collaborate on it, actually. Yeah? So they're also okay with spending the effort and investing way in front of their projects to make it happen. So they understand that, because that's also what their business is. You have to invest first, and then you get the profit. And here the profit is perhaps not money, but they want to reduce their impact. But of course, especially also these students here, yeah, they're really important to us as well. So we collaborate a lot with the universities, but also, for instance, together with Damen and other shipyards. So we do collaborate, not always in the best way, but I see a lot of collaborations there. For instance, in the Netherlands, we have a massive project between Damen and also Vetship on making the transition towards methanol happening. So we are in this project is a 25 million euro fund through the Dutch government in the industry in order to make that transition. So we are currently working on a proven principle of a fuel system which is fuel flexible for both diesel and methanol. And for sure we will start building all yachts like that in the near future.
Thank you.
Okay, we're at Leursen. I think we have to divide between R&D, something that we do years ahead of a real yacht project, and innovation that we, which might be driven by an owner and that we have to realize within 2 or 3 years. So what we do in innovation for our yachts is, of course, there's a lot of money, it's a big budget, and but this is always related to a real project. But we also do a lot of R&D, which is like years ahead of any yacht project. For instance, what we started in 2005 when I joined Leursen with our first fuel cell project. And now, 20 years later, we will deliver the first yacht. And this would not have happened if we hadn't done R&D in 2005 already. And in 2005, not everybody in yachting was very convinced that fuel cells will be a very smart option in the future. But this is something that we need to do to be, or to anticipate what will be needed like decades ahead, or at least many years. And so the fuel cell is only one of those R&D topics that we have done, but we also started in 2008. We were looking for a substitution of teak. That wasn't that big of an issue back then, but today we know it's very hard to get legal teak right now. And so we started that development many years ago, and about 5 years ago we finished that development and said now it's ready, and I think it can be used on yachts. And so we licensed that knowledge to a startup company, and they are producing already that new material. It's called Tesumo, and I think that will be a very good option, alternative to teak or other wooden decking materials.
Thank you.
At Damen, we have our own dedicated R&D division that is not only for yachting, but for the commercial side as well, mostly. But we can tap into a large pool of innovation and ideas from them, like electrification, electrifying tugboats or ferries. We're not looking into electrifying yachts completely, but we can learn a lot from the propulsion train there. Together with them, we create our proven platforms. So the limited editions that Amels is doing are proven platforms. So the willingness does not come from the owner, but we try to create something ourselves. And not much, rather than innovating, maybe we're trying to anticipate future changes and requirements. So, for example, in 2018, we were able to deliver the world's first Tier 3 compliant yacht. So, for our new series, because we knew it would run for a few years, and we had to be ready for the future. And on the custom side, then we can rely on the willingness of the owner. So for diesel electric propulsion, for example, or whatever comes ahead, we kind of rely on the owner on the custom side. Yeah.
Thank you.
From our side, Ferretti Group, what we need to take in consideration is, let's say, short-term application and long-term. As we've seen, since 2008, we launched already the first hybrid unit. Today, we have an hybrid unit for the Ferretti Security and Defense unit, so that is a patrol boat. Let's say that we made a lot of things by ourselves together with some suppliers, external suppliers. And I think one of the interesting thing is later in this year we will launch full electric prototypes. Yeah, let's say that it's quite important trying to improve during all the periods and trying with the small things, but of course studying and getting better for the next challenges.
Okay, thank you. Well, I'm going to carry on being touchy upon what the students do. It's like afterwards there's going to be a tech talk. And the tech talk they do here during the challenge is open source. So the question for you, when you talk about sustainability and collaboration, how much of your R&D becomes open source, or you talk about collaboration? Is it something that you think is getting better in the industry, or is everyone's doing their own?
Maybe to come back, what was mentioned before is the collaboration between multiple Dutch shipyards and also testing facilities on projects to reduce the emissions of yachts, for example. Then we have the Superyacht Builders Association, also where also Lürsen is part of, where we also create projects to work together to also spread knowledge, spread experience, and not do the same mistake over and over again, but learn from the others and progress a bit faster like that. Yeah.
Okay, thank you. Now, the reason I ask is because a lot of discussions today were about how the automotive world also transferred, some solutions into the maritime industry. And as everyone knows, is that even though there may be competitors on the marketplace between different types of cars, there's a lot of collaboration for industrialization of solutions as well, in order to be able to reduce costs and stuff like that. Something that we don't feel that we've seen much in the yachting industry.
I don't know if somebody else talked about it earlier today, but we are part of something called the Water Revolution, which you may have heard of, which is an industry group across the board, shipyards, designers, where we talk about various aspects of sustainability, and where it's all open source. We look at specific project, we share it all with each other and share our findings. And I think that's a very good example of a real collaboration between all the various sectors of the industry, shipyards, designers, suppliers.
Okay, thank you. And I wanted to add something.
When we do our...
It's Peter Lürsen calling.
Excuse me. What I wanted to add is when we do our R&D projects, most of those projects are in collaboration with universities, with other shipyards. Most of our R&D projects are funded by German government, and then we're collaborating with Meyer Werft and other shipyards, Arbekin and Rasmussen, and so there's a good collaboration within our community, at least in the German community. And there are a lot of universities or Fraunhofer institutes that we are working together with. And all these projects that are funded, of course, the final reports are published, so everything is open source in the end.
Yes, perhaps one thing to add, and we had a debate on it during the last Yacht Code Development Committee in Amsterdam, and also Lloyd's Whitetech meeting, is that a lot where what we debate here will be subject to so-called risk-based design exercises. So you have to perform hazards, you have to do alternative ways to prove your design will be safe. I think there is a challenge to share what you have learned, because it is a common effort, I would say, to make it happen. And with Engel, we discussed how are we going to do this, because that's actually quite challenging to do that. Because a hazard report, we have a couple, we can't share that because you will see a name of a vessel recurrent because it's a refit or so, or a new design that you can't publish.
Other hazards from commercial ships, you can just Google them, you find them. You see what actually the risk assessment was, what all the specialists around the table said. So it's that's a part of openness that we need to look for. But we have a very difficult situation that we have these confidential projects, and especially more so confidentiality towards clients. But anyway, it's a problem to solve, but I think there's quite some room to further cooperate.
Okay, thank you. I've got a question for Simon. He's been silent.
Thank you.
The level of experimentation of R&D that is being developed, whether it's at the shipyards or naval architecture engineering firms, how much of it is in fact linked to propulsion, which is obviously a key topic today, but other areas as well? I mean, do you investigate into R&D for materials? We talk about reduction of energy consumption. So what are the other areas?
Absolutely. You know, I mean, I think what we're really keen to sort of always push the message that it's a whole ship design. It's really important to think of everything holistically. You know, so within our the work we do, we consider the structural design, the mechanical, the electrical design, the naval architecture. It all has to work together. You know, and also we have to collaborate with industry partners. We have to collaborate perhaps outside of our industry to find people to work with. And that really only happens when you consider the whole thing holistically. And I think, you know, for us, that's really where we see a lot of our, you know, we try and put our public face to R&D is by putting out some quite regular sort of concept designs. We try to be as open as we can about what's happened in those concept designs. And we try to really progress really what we think the important ideas that come out of that R&D are. You know, obviously some of this work is quite detailed, and you know, I don't think anyone's going to read a 50-page technical report that we put out. So we're really trying to make some of these ideas accessible as well to everybody. And we see the concept designs which we've done in the past and which we'll continue to do in the future as really the key ones there. And when we do that, it's really a whole ship design involving everybody who would be involved in designing a ship, really.
But from that R&D, and when you think about, I remember FedShip launching, you know, the new concept at every Monaco Yacht Show with new solutions many years ago. When you develop this concept, this new engineering, these new solutions that obviously are aimed at reducing the environmental impact, how much of that actually turns to reality, whether because someone is a client or the shipyard will make it, I mean, will execute it, and how long does it take? I had the question before, I asked the same question for other situations. How long does it take between the moment you develop, you think, you engineer, you look into your R&D initiatives, and the reality of that coming into a real product that then comes to the market, to all of you?
I think, you know, the answer to does the concept design drive client engagement? Yes, it absolutely does, yeah. Do you end up building yachts which look exactly like the concept? No, you don't. You know, but what it tends to do is you know, we get a lot of people come to us and say, I like what you did there, but can you also do this, or can you do that? And then that becomes a real project. And that then starts in our normal engagement process for a new project. I think what's perhaps interesting, you know, we do a lot of upfront work, sort of first engagement with clients. You know, so I think sometimes you really could imagine a 12-month, 18-month period of just engaging and discussing with clients before they even go to shipyards. And during that period, that's where you're really trying to get the important bits settled. You know, which bits are you going to take a risk on, which bits of the R&D, you know, which bits are you going to pick up on and run with? You know, so for us, that's how it works. You know, I suspect maybe slightly different for everybody.
Yeah, I think if we take a couple of examples, that makes that works best, I think. But for instance, in 2010, we had the Breathe concept, as it was called, and then Savannah is based on the Breathe concept, which was ordered months after. So that was really short. But it's more concept design, it's more about hull lines and propulsion arrangement and engine layouts. It's not fundamental technology development, so to say. So because that takes much more time.
But that said, we did a lot of work on fuel cells, hydrogen in the past, maybe a decade of work of different levels of detail, and that's also resulting into projects now. So that's a more longer-term development because you're also very much dependent on the development of your supply chain, of the system suppliers.
Yeah, I just can say that's totally right what you say. It's the same thing at Lürsen, of course. As I said, we started in 2005 with fuel cells, and now it takes like 20 years. In 2014, we started a development for an exhaust gas after treatment system, and that took only like 2.5 years. And then we already built the first system for first yacht. And there are other innovations that are directly driven by a project, and there you have a time limit of like starting with a project until delivery, and that is maximum 3 years. And then it has to be done. But this of course cannot be, that needs to be like a reliable technology that you are able to develop in that time frame. So that cannot be a fuel cell or something like this. So this is something like more related to a direct project with this rather development than research.
Okay, thank you. Any other? Yeah. So I've got some other questions, and I'm sure there will be some. So on the R&D side, I mean, as we said, you know, a lot is for propulsion. Do you think that there are other areas when it comes to the design development of a yacht from all aspects, from all angles, that could be, should be given more look into in order to speed up the decarbonization and lessening of the environmental impact of yachting?
Maybe if I can start, for us, waste management, so generally looking into the operation of the yacht. Waste management is one thing that we want to look into, and noise emission. There's more and more research on underwater noise emission, how our boats affect the environment at the anchorage places, but also during the way. So these are the things that need more attention, and yeah, not only decarbonization is the solution for a sustainable yacht, let's say. Yeah.
Thank you.
From our side, I think it's as the presenter of the Black Pearl yacht earlier, it's really important to keep in mind that a lot of things can be made looking at interaction between props and the hull. So it means that with new ideas about hull shapes, interaction within props, and some other ideas, I think we can do some steps forward. I mean, always keeping in mind that we need to find the right compromise between the contents required by the clients. So it means cabin and space available and what we want to offer them. So I think the fields there is still space to improve. So, and all the other technology, of course, we are looking as well to reduce the carbon emission and the lightness of the yacht. It means a lot, since you can decrease the size of the engines, and so it can make even more feasible electrical solutions that at the moment we need to move yachts that are quite heavy compared with the ideal yacht that is that Espen was showing earlier, that is quite light.
If I may add as well, I think that on the propulsion side or on the resistance side, when the boats are underway, I think it's interesting to see how today the renaissance of foiling, you know, foiling is nothing new, they've been around since ever. I remember as a kid we had lots of fast ferries, Italian-built fast ferries, foiling ferries in Norway. You can still see them in the Bay of Naples today, you can still see them in some of the lakes, and in Greece and in Russia. But today, with the lighter materials and different propulsion systems, it's really been an incredible renaissance in terms of foiling. So combination of new technologies, lightweight materials, making it easier also in terms of arranging the propulsion, not these huge shaft lines with a terrible, inefficient angle of shaft lines, but with pods. On we just completed a small foiler 14-meter catamaran, foiling cat, which I tried last weekend for the first time, but with the sea trials in Holland a few weeks ago. But she's here now, and that's part of a internal little research program we have in our office. We're working with a partner company in Canada on this, and I'm quite hopeful that this is one way of reducing resistance further. On the hotel side, which, as I said earlier, I think it's actually possibly more important for a yacht, not for a ferry that goes between A and B every day, many times rotation a day, but for a yacht where you spend most of the time at anchor or in the port. I believe that from the electrical load balances we look at, the air conditioning system is a huge consumer. And I believe that in combination with the fact that at least every time I'm on a yacht, I'm always outside. And I'm not the only one. And the reality is that when you're on a yacht in good weather, you get up, you have your coffee on deck, you have your breakfast on deck, you have lunch on deck, you have dinner on deck, and you spend very little time inside. And I believe that today's yachts are not really designed around that. We need to create more open spaces, protected open spaces, protected from direct sunshine, from rain, from wind, but and reduce the many unused internal spaces, which are huge consumers on air conditioning. And also in the way we design our yachts, big overhangs to try to direct and avoid direct sunshine on big glazed surfaces and so on. I think this is a way to go. We might end up with, we're working on a concept now whereby we're literally trying to look at the marinizing in a Bali beach house, where basically just the cabins or your bedroom is air conditioned and the rest is not. It's all natural ventilation.
Thank you. Yeah.
Sounds great. I really like those concepts, Espen. Yeah, I think that's the way to go. It starts with a fundamental, with a fundament. Because there's a lot to gain there.
It's back to the basics, like my little rowing boat.
Yes. So you cool something which is in the core.
Yeah.
Like how they built buildings in the past, centuries ago. Yeah. What we also see is that if you look into the actual use of the yachts, and there's an ocean of data, as we often refer to it, that we have more and more access to, there are so many easy steps to take, which have a considerable potential gain. Perhaps not everybody knows, but in average, well, also fat ships, but pretty much all yachts, have 30% of sea margin, which means you need 30% more power to sail around than when your hull, your propeller would have been clean. So that's, and the propulsion is half of the energy use, and hotel half of the energy use, pretty much, typically. There's a lot to gain there, because there are other systems available. There are ways to clean your hull. Also, when we look into the use of the yachts we have the best data on, the AC system is set at the lowest temperature when they cross the Atlantic. Why? Why do you do that? Yeah, we can make a very efficient AC system, but why do you cool it to the lowest temperature while there are no guests on board? That's weird. So there's a lot to gain there, a lot to educate, a lot to make it more smart.
But is that being taken up by the yacht owners and and the ones? Are they telling you about these, or the education means that you have to explain to them, and whether they accept it or not? What's the evolution?
I think that's a really good point, and Guido alludes to it. It's big data. Big data is changing this picture now. So you look at the sensors and the amount of data that's recorded on a yacht today. It's many times more than it was probably 5-10 years ago. And that's really enabling perhaps a clearer communication between the operators and the designers about what these yachts are actually required to do. I think that is a really, is a bit of a revolution. We've seen it already affecting the sort of speeds which yachts are happy to be specified at these days. Generally, the last few years, there's been a trend towards lower speeds, more representative of what yacht owners actually want and need and use. And I think, so this is a really positive thing. I still think there's a problem that, there's quite a variation between how owners use yachts. But, certainly for particularly repeat yacht customers, it's an incredibly powerful tool.
I totally agree with everything what my colleagues here said already. There's a lot of potential to optimize the energy consumption on the yachts, but there still will be some rest of energy that we need to produce. And to get this to zero, we need e-fuels. That's the only way, from my opinion, to really get carbon neutral. And the most important fuel for the future, I believe, will be methanol. And the good thing about methanol is it's available already today, and there will be a lot of production plants are planned and will be built to produce green methanol. And there's not the problem that we have a hen and the egg, but there is methanol and it will become green in the near future.
We'll talk about it tomorrow, in fact, during the Hydrogen Working Group roundtable, these questions.
Yeah, I know, but you have to tell it every day, 10 times. We need to make sure that in 3 years that we can bunker methanol here in Monaco.
We'll discuss tomorrow, and the Monaco people will be here as well, so we can spread the message. Thank you, gentlemen. Questions from the floor? We've got about, 3 minutes for questions, and then we'll have to conclude.
Thank you. My name is Jay. I'm from IUM. Going back to collaboration, earlier we mentioned the auto industry. And for example, Ferrari has a projection to create 60% of their line to electric by 2025. So considering there are similar clients and interests and shared problems, to what extent are the opportunity and challenges of working cross industries to solve more of the energy problems? So as you can imagine, maybe he has his Ferrari, it has to be electric because he likes that, but then he goes on his yacht. Like, what are there room for collaboration, and to what extent are the problems of bridging that gap?
Yeah, I mean, there's definitely happens. In the UK, we're very fortunate to be the centre of Formula One. So quite often we're talking to Formula One teams, Formula E teams, about batteries, about energy recovery and things like that. And I think when we have these discussions, it's often incredibly fruitful and stimulating for both sets of engineers. But often there is quite a gulf in requirements. And actually, it's somewhat interesting. Sometimes, actually, we find ourselves sort of, for the stuff that we do, almost further along than some of these other people. Other times, it's amazing what they're doing, but we just can't bring it directly across. But I think what it does is it always sparks that imagination, and that does bring a lot of creativity sometimes to the way we think about things.
Thank you. Somebody else wants to react? Fine.
Yeah, well, I do see a lot of crossover. If you look at, for instance, the fuel cell technology, very much relevant in this audience and in this energy boat challenge. A lot of the developments have been done in other industries, and we can apply them now. But there are yachts, and especially yachts going cross Atlantic, sailing all 7 seas, so to say. It's very different than a car. You can't compare them. So you have very unique challenges, and especially when it comes down to the fuels. Oh, a Ferrari in the yachts, you mean? Yeah.
Yeah, I think the thing you got to see is actually, a lot of these guys are invested in automotive technology. A lot of our clients have got interest in other companies. So, quite a lot of times the urge to collaborate comes directly and quite strongly from the client as well, doesn't it? So,
yes.
We see that quite often as well.
Yeah.
One last question. And feel free to have a chat with them afterwards or tomorrow.
Question for Lersen, really. I'm a big fan of the use of methanol. We can see it developing in the shipping industry as one of the most promising fuels. But one of the issues with the use of reformers and fuel cells is the additional footprint that the reformer adds to the installation. Has that been a particular problem for the project you're developing?
Actually, when we were looking for a partner to develop this type of fuel cell, we spoke with almost all of the known producers from Ballard, etc., everybody that you know, and nobody was willing to make an integrated system. So finally, we ended up talking to Freudenberg, and they were the only one that said, yes, we want to build an integrated system consisting of a reformer and the fuel cell. And so we don't have this, so we get a complete system, so we only have to supply fuel and air and maybe some water and so on, but everything is in complete integrated system, so a whole integrator. And so the additional footprint of the reformer actually is not a real big problem. It's the system that we are developing right now, or that we have developed within our research project, is from the energy density so la la, I would say, but that was not the real aim of the project. The aim was to demonstrate that it's feasible, that it's functional, that it can work together with yacht peripheral systems. So we have built a demonstrator where everything is existing, that it's existing on a yacht itself. We have a switchboard, we have a tank, we have air conditioning, we have ventilation and everything. And that can be tested in long-time operation under normal or special conditions. And based on these experiences, Freudenberg develops now the 500 kilowatt system. And that will be, of course, a much higher energy density, much higher efficiency and everything. And the total footprint, I would say, will not be much bigger than of a normal diesel engine in that size.
Thank you. We will, in fact, I mean, it's a good conclusion and opening to tomorrow's session, because the hydrogen working group, the roundtable, is specifically about this question, so we will delve further into it. Thank you, gentlemen. I very much appreciate your contribution. And in order to conclude this afternoon session, I will call on stage Mr. Mike Horn, who's going to give us the concluding words from having attended the sessions and what his thoughts on it were. And in the meantime, if you'd like to give these gentlemen a round of applause, thank you very much. So, Mike, you will have 6 seats just for yourself. But in fact, you don't have to sit. Please, Mr. Mike Horn. Thank you.
Thank you. Do I need this? It's always the best to do the conclusion, because then we can go out and have a couple of beers. So thank you very much. I think it was quite informative. But I think we've got to stop comparing what we had and what we will have in the future. We mustn't see the past better than what it was, and the future worse than what it will be. It's not going to take us anywhere. So we've got to forget about what we did wrong and think of what we can do right. So basically, it's the way that we change our minds that's going to change the way that the future will be determined. If we keep on comparing fuel with hydrogen or battery-powered electricity, we're going to always find the excuse not to use innovative technology. Yes, we are at a certain stage of maturity that allows us to easily supply a solution to our clients. But we're always thinking of making as much money as we possibly can and to have the maximum range. We've got to stop saying that half of the hydrogen capacity will be lost if we use hydrogen instead of fuel. You've got to give the people the facts of the technology today, and that's what they have. The planet has no longer any time for us to doubt and discuss on what we should and should not do. I'm a professional explorer for 30 years. I sailed 27 times around the world. I crossed both poles. I climbed the highest mountain. I swam down the Amazon. I've seen the world change like few people has. I've got a little video just to show you. A couple of months ago, I did some stupid thing climbing icebergs in Svalbard. So, what's happening with this little iceberg while we're climbing it is it's actually toppling over. We can just relaunch it a little bit so you guys can understand that that iceberg is our world. We're busy toppling over without actually knowing. So what made this iceberg turn? Is it the fact that when the iceberg was drifting backwards, I pushed my boat against the iceberg and I destabilized the natural flow of the iceberg, the drift? Was it that? Or was it that two guys weighing 85 kgs got onto the iceberg, added a weight of 160, 170 kilograms to the iceberg that made the iceberg topple over? Do you think it's the weight of two people? Could be. Okay, so we stopped the natural movement of the iceberg. We added weight to the iceberg. And then the boat moved away. And when you put the motors of the boat in reverse, the prop wash goes where? To the bottom of the iceberg, and pushes the bottom of the iceberg in the opposite direction that it should go. And that's what we're doing with the world today. We're adding so many little things that's going to make us topple over. And I think that today we have an opportunity to say, okay, what was in the past was there, and the future will be different. To be able to give solutions and not comparisons is the way to move forward. And to be able for us all to work together, because working together is the new competition in life. If we can work together, we can find solutions, I think. So, a couple of months ago, we started a small company, InnoCell, fuel cells. We get told every day that hydrogen is not the solution, and we should keep on polluting and destroying the world. So, I think we've got to be open-minded and see the potential of all the different technology to be able to add to the future of our planet. And with that attitude, by changing the way we think, supporting and not only criticizing, we can move forward. We've got to be united, especially in what is happening in our climate today. We're speaking about anxiety under the youth, environmental anxiety. What we're living through now is not because of the war. It's just because of COVID. The war's going to add to that. And then the environment changes is going to add a lot of pressure to us. So we do not even know what's laying ahead of us. For us, I think it's a moment to play a role actively in participating in changing the world. And if I can conclude a conference like that, that was so much said. What are you guys going to take back out of this? What was the key message? And I think you guys have the moment to reflect on what you want to take back home and how you're going to take that information and turn it into action. If you're just going to go back, you've wasted your time. And I think we've got no more time to waste. So good luck, guys. We'll keep on exploring the world. We'll keep on trying to save our planet. And we need it done in the super yacht business, because that's where we can really make the changes. You can make it where there's money. So let's make the changes where we can make them. Thank you very much.
Thank you, Mike. On these last words, I strongly invite whoever has not been down to the docks to see what the students, the universities, the teams are achieving, the innovation, the ideas, and the enthusiasm and optimism they bring to the table. So on these last few words, thank you all for attending. It's been a long day. Lots of interesting stuff said and exchanged. Hope you also had the opportunity to discuss amongst yourselves and meet new people as well. Back tomorrow morning, and until then, please do go down, listen to the students and their open source tech talk, and see you soon. Thank you.